ये जो आज हम कर रहे हैं मोस्ट एक्सपेक्टेड क्वेश्चन, ये तुम्हारे लिए तो लाइव है, इसी के साथ साथ इसका रिकॉर्डिंग वुड गो लाइव ऑन द यूट्यूब, डेल्टा का यूट्यूब पे भी ये लाइव जाएगा ये सेशन के बाद. तो दिस वुड बी एन रिकॉर्डेड सेशन एंड द होल जनता, मतलब सारी जनता ये सेशन देख पाएगी, क्योंकि ये मोस्ट एक्सपेक्टेड क्वेश्चंस वाला हम फ्रॉम लास्ट ईयर हर एक अटेम्प्ट से पहले करवा रहे हैं. तो सिमिलरली इस बार भी वही कर रहे हैं. सो मैथ्स और एलआर दोनों में टॉप 10 क्वेश्चंस लाइव हम सॉल्व करेंगे अभी, जो कि मोस्ट इम्पोर्टेंट होंगे, एनसेट से एकदम रेप्लिका होंगे क्वेश्चंस के एंड ऑल. ठीक है, तो हाँ 9-7-9-8 पे स्टार्ट करते हैं और 4 मिनट वेट कर लेते हैं लोग, अगर कोई और बाकी है ज्वाइन होना एंड ऑल. तो 9-8 शार्प विल स्टार्ट. तब तक किसी को कुछ पूछना हो रैंडम किसी भी चीज के बारे में पूछ सकता है. Oh, sure. Done. I'll take care. Make sure कि I'll take the session in English. Sure. Thanks for the feedback, Vishwa. Headphones use, I think so. Will not be able to use headphones exam में. Calculators are allowed, but as far as I know, headphones are not allowed. So it means you can check with your counselor if counselor is appointed to you, right? You can ask them or ask the scalar team also. भाई स्केलर में डिग्री का क्या सिस्टम है? वो ऐसी डिग्री मिलती है जो बिट्स पिलानी के बच्चों को मिलती है. नहीं तो लाइक देयर आर टू वेज. मतलब वी हैव 2 डिग्रीज का यहाँ पे है इन एसएसटी. वन इज आईआईटी मद्रास एंड अनदर इज बिट्स पिलानी. बिट्स पिलानी इज BSc degree or BS honors 4 years, right? I mean, you can take either 3-year degree or a 4-year degree. You can do an honors or if you want to do it, or you can do a BS degree in computer science, right? It is not the same degree जो बच्चों को बिट्स में जाके मिलती है, राइट? क्योंकि उनको मिलती है BE डिग्री, लाइक बिट्स गिव्स, बिट्स के सारे कैंपसेस में दे गिव्स BE का डिग्री, बैचलर ऑफ इंजीनियरिंग. बट ये वाया कोर्सेरा दे गिव दिस डिग्री वाया कोर्सेरा. सो दिस इज एन BS डिग्री जो कोर्सेरा के थ्रू होती है. एंड टॉकिंग अबाउट IIT Madras has the same thing. Anybody from India who is qualified for JEE Advanced is eligible to get a degree through IIT Madras. If you are not able to qualify for JEE Advanced, then you need to give I think as far as I know, then you need to give a test, and then you can take those degrees. For both BITS and IIT, teaching would be completely online. I think so there are only 1 or 2 live classes a week, and other than that everything is recorded. In BITS the exam is also online, while in IIT you have to go to the nearest center to give the exam. That's just one difference. So this is about the degree. So one thing, degree doesn't matter anywhere. I mean, me myself has given interviews in big companies and also have done an back-end intern in one of the company, and nowhere, in neither in one, also in any of the interviews, I was not asked about my degree anywhere. So yeah, degree doesn't matter. 2-day strategy for the exam and anything related to exam. 2-day strategy, just means focus on the most important topics, like in math, focus on PNC, probability, right? number theory, these 3 topics. And LR, as far as I know, you can focus on clocks and calendars, blood relations, sitting arrangement, coding, decoding. This 3 to 4 topics, which are most important, and you are sure, means we are sure that there would be a question from these topics, right? So this would be the last question. Then we'll start. How much MS foreign degree helps for foreign job and settlement? First बताओ, no idea. Like this MS foreign degree from Wolf. Means till now we have zero clarity about it and how and what we will get the degree from. But yeah, it is accredited by EU, so it would be better. Settlement, no idea. Foreign job, most probably it would help. But like me myself, BITS ki degree is very much okay for the foreign job. So this MS wali degree, if we are not having also, then it's also all right. Okay. Now I'm sharing my screen. If you guys can tell me that if the screen is visible, just a second. Let this be open. Yes. Great. Share the window. Share. Hide. Yeah, can everybody confirm if the screen is visible? Screen is visible? Yes. Patel Dhruv, Patel Jahan Dhruv, done. Okay, so as discussed, so today we'll start from maths. We'll start off with maths. We'll discuss 10 most important questions from maths and from LR. From maths, I'll cover all the questions from PNC and probability. Saurashish would cover the questions of number theory, exponentials and logs and the ratio proportion part, right? Similarly for LR, we have Krishna. Krishna would be taking all the 10 questions for LR, right? So we'll start off with math. I will just start my slideshow. Pen is working. Done. Yeah. So before we start, all the questions which we would solve today, they are the most important questions, and this type of questions, these are the replica of the questions, right? And one more thing, I would not be able to see your chats while I am explaining and all the things. So make sure that you share all your doubts in your chats. After I complete my part, I will see all your doubts and would solve all the things, right? So yeah, we'll start now. So yeah, let's move forward to the first question. Yes. So let's read the question together. In a geometry workshop, a student draws a triangle ABC on a sheet of paper. To explore polygonal patterns formed within the triangle, several distinct interior points are marked on its sides. Specifically, 3 points are marked on side AB. Okay, so there is a triangle ABC. Triangle ABC. Okay. Then it is said that on side AB, 3 points are marked. Okay. On AB, 1, 2, 3. 3 interior points are marked. Okay. 5 points on side BC. On BC, there are 5 points. 1, 2, 3, 4, and 5. Okay. And 6 points on CA. CA pe, there are 6 points. 1, 2, 3, 4, 5, 6. Done. Okay. Now, with all points lying strictly between the vertices of the triangle. Okay, done. Only using this marked points as vertices, the students now investigates the different quadrilaterals that can be formed inside or on the boundary of the triangle ABC. A quadrilateral is considered valid. I think that everybody knows what a quadrilateral is. It is a shape with 4 vertices, 4 sides, right? This is a quadrilateral. A square is also quadrilateral, a rectangle is also quadrilateral, a kite is also a quadrilateral, parallelogram, trapezium, everything is a quadrilateral, right? So there is no such things of sides equal, angles, right? So there should be 4 vertices and 4 edges, right? All the 4 vertices are distinct marked points, right? Is considered valid if all the 4 vertices are distinct marked points. Okay. No 3 chosen vertices are collinear, right? So in the question only they have given that if the 3 points are collinear, then there is no way that we can create a quadrilateral using 4 points, right? If 3 points are collinear, then we can't create a quadrilateral. Then only we can create a triangle using 4 points if 3 points are collinear, right? Okay. Now what is the question asking? The question is asking us to find the total number of distinct quadrilaterals that can be constructed using these points. Okay. So total how many points do we have? 3 on AB, 5 on BC, 3 on AB, 5 on BC, and 6 on AC. So total how much do we have? 6 plus 5 is 11 and 3, 14. Total we have 14 points, and out of these 14 points, for choosing a quadrilateral, how many vertices do a quadrilateral have? 4 vertices, right? So all these 14 points are nothing but they can act as a vertex, right? So can we do 14C4? What does 14C4 does? It randomly gives us any 4 points, or it randomly selects any 4 points out of this 14 points, right? It can give 3 collinear, 4 collinear, it can give 2 collinear and 1 extra, 2 collinear in 2 sides, everything. So this includes everything, right? So this is the answer. Is this the answer? 14C4 is the answer? No. Why? Because there can be a case where all the 4 points that we have chosen are this 1, 2, 3, 4. Can this 4 points give an quadrilateral? No, right? So what we have to do? From the total, this is total. You know about inclusion exclusion principle, right? From the total, you have to subtract those those number of ways in which we can select 4 points, and all the points are collinear, right? So from total, we need to subtract collinear points. Collinear points. How many points? 4, right? Now, are 4 collinear points possible on AB? There are only 3 points, right? So on AB, there can't be 4 collinear points. Okay. There can be 4 collinear points on BC. So what are the number of ways of choosing 4 collinear points out of the total points of BC? How many points does BC have? 5. So 5C4, these are the number of ways we can select 4 points all on BC, right? Similarly for AC, there can be 4 points chosen such that all the 4 are collinear, right? So how many points does AC have in total? 6. So can we do 6C4 to get all the possible number of ways? These are all possible number of points which are collinear on side AC. Similarly, this is nothing but all possible number of points which are collinear on side BC. Talking about AB, there are 3 points. Selecting 4, we can't select 4 points out of 3, right? So on AB, there would be no such points that we can create a collinear points, right? Okay. One more thing. So 4 collinear we have. So from total, we need to subtract this 5C4 plus 6C4. Okay. Anything else? Or this is the answer? No, right? We need to subtract 3 collinear, right? It was given in the question itself. No 3 chosen points should be on the chosen vertices should be collinear, right? So if there can be a possible case where these 3 points are chosen and one of the point is chosen as this, the 4th point. Can we create a quadrilateral using this? No, we can only create a triangle, right? So what other things we need to remove is that the 3 points collinear, right? So, okay, now talking about that, talking for at side AB, there are 3 points. We need to select 3 points, right? From 3, we need to select 3 points. Okay. But what do we need to create? We need to select 4 points, right? So 1 point is remaining. How many points are remaining? On side AB, there are 3. On side AC, there are 6. And on side BC, there are 5, right? So remaining points are how many? 11. 6 plus 5, 11. From those 11, we can select any 1 point to create, to get 4, to select any 4 points, right? So this creates a triangle. This creates a triangle. We have to subtract this too. Similarly, on side BC, BC has 5 points. 5 points means we select 3 points. This 3 points create a collinear 3 points, right? So this 3, if we select this 3 points, right? Now we can select the 4th point anywhere from AB and AC, right? AB and AC, how many points are remaining? 8. So there would be 8C1. We have to select 1 point out of from AB and AC. This also creates what? Triangle. Okay. Then talking about AC, how many points are that on AC? 6. We select any 3 points. Now, how many remaining points? If we select AC, 8 points are remaining, right? See, this is the mistake. On BC, there are 5 points, right? How many are remaining? 9 points. So this is not 8, but this would be 9. 9C1, right? 9C1. On AC, there are 6 points. Remaining points are 8. So this would be 8C1. This would also create a triangle, right? So we need to subtract this 2 also from the total, right? So let's calculate. So total kitne hai? 14C4. 14C4 if we calculate, this is nothing but 14, 13, 12, 11 upon 4 factorial, 4, 3, 2, 1 is okay. But yeah, 10 factorial got cut, right? So 4 3s are 12, 2 7s are 14. This is nothing but 7 3s are 21, 7 1s are 7, 8, 9, 91 times 11. 11 ones are 11, 1, 11 nines are 99 and 100. So there are total 101 possible ways. Now we need to subtract this, right? What is 5C4? 5 factorial upon 4 factorial, right? This is nothing but 5. What is 6C4? 6 into 5 upon 2, right? 2 3s are 6, 5 3s are 15. So how much? This gives us a total of 20. Okay. Now, what is 3C3? This is nothing but 1. What is 11C1? It is 11, right? Okay. 11C1, 11 factorial. You know the formula of NCR, right? 10 factorial into 1 factorial. So this gives us 11. Similarly, what is 5C3? 5, 4, right? Upon 2. 3 factorial got cancelled. 5 minus 3, 2. 2 remains. This gives 10. This is 10 into 9C1 is nothing but 9. So this gives us 90. This gives us 11. Right? Similarly, calculating for this, 6, 5, 4, 1 3 factorial got cancelled. Another 3 factorial, 3 2s are 6. 5 4s are, this is 20 times 8. This is 160. So if we total it out, 160 plus 90 plus 11, this gives us 1. 9, 10, 16. This gives us 261. 261 plus 20 plus 20 gives us 281. So what we need to do is 1001 minus 281. This gives us 0, 10, 9, 0. This is what? 2. 9 minus 2 is 7. So 720 becomes the answer to this question. Everybody got? Got it? How did we did this? Right? So this is very important question, and in this question there is nothing, right? From total, this is a question of inclusion exclusion principle. Inclusion exclusion principle of PNC, right? This question is based on inclusion exclusion principle. So what? Out of total, we need to subtract those number of cases which through which we can't create a quadrilateral, right? So there are two such cases, right? One of the case is that 3 points collinear, and another case is that all 4 points are collinear, right? Right? Can be any third case which we need to subtract? Can be any third case that we select 2 from a side and see, if we select 2 from this side, okay, and 2 from this side, okay, then also we can create a quadrilateral, right? This quadrilateral can be created. If we select 2 from 1 from this side and 1 from this side, then also a quadrilateral is created, right? So, okay, that case is not possible. So, no other cases are possible. Only these 2 cases are possible, right? Now, one more thing. Are there any intersection between these 2 cases which we need to add? Which means, are there any intersection which is getting subtracted in 2 times, in 1 also and in 2 also? No, there is no intersection, right? Selecting 3 points and selecting 4 points, there are no intersections, right? So that is also not the case over here. So what only we need to do is that from total we need to subtract this both, right? So after doing that we get answer as 720. Yes. Now doubts, I think so. I hope that everything is clear to you guys. I can't see the chats. This is the most difficult thing. But if I can join on my phone, I can see your chats, I think so. Let me join on my phone. So I can also see your chats live so that I could clear all your doubts there and there itself, if there are any. I will join the meet using this ID. Oh, I can't join. Okay, let me join it using this. Just a second, guys. Just a second. I'll mute myself. I'll lower down the volume so there is no 2 times the volume. Okay. Anyway, I can mute myself as turn off sound. Right. Okay. Okay. Let me see the chats. Are there any questions related? Yeah. Okay. I can't. So past chats are gone on this phone because I've just joined. If you guys can retype your doubts if there are any, so that I can clear all of them right now. No doubts, right? Okay, great. We can move to next question then. Chalo. Okay. Again, let's read this question. Rohan's grandmother is preparing a healthy fruit plate for him from a large basket kept in the kitchen. The basket contains a mix of fruits. 7 red apples. Okay, there are 7 red apples. Okay. 5 white apples. Okay. What are white apples? But okay, chalo. 5 white apples and 8 oranges. 8 oranges. Okay. Crazy. Done. All fresh and ready to be eaten. She plans to select exactly 5 whole fruits from the basket to give to Rohan. Okay. While choosing fruits, she wants to make sure the selection is well balanced. Okay. She decides that the final plate must include at least 2 oranges. Okay. She needs to select 5 fruits. Okay. That is one given information. And there are some other conditions given. Okay. Let us assume that X is equals to number of red apples. Y is equals to number of white apples. And Z is equals to number of oranges. Okay. It is said that X plus Y plus Z should be 5, right? Now, what it is saying that the final plate must include at least 2 oranges. Okay, at least. So X should always be greater than or equals to 2. At least one orange is what? Z. So Z should be greater than or equals to 2, at least one red apple is x, at least one red apple, right? Greater than or equals to 1, okay? And at least one white apple, okay? And one white apple is y, and okay. So those are the constraint. This is the equation. What we need to do is to find the possible integral solutions, right? Is that the case? So is this the question of Beggar's method? Beggar's, where you are getting an equation, there are some constraints, and you need to solve. Is this the question related to that thing? Can you guys tell me? Is this the question of Beggar's, or is this the question of any other logic? All the people saying it live. Can you guys? Okay, Harsh is saying that this is of Beggar's method. Kavya, you are also saying that is this of Beggar's method. Okay. Now, recall one thing. For what thing Beggar's method was used for? For arrangement of which type of objects? Like objects, right? For arrangement of like objects, Beggar methods was used, right? But are the objects like? Are red apples same as white apples? Are white apples same as oranges, etc., etc.? No, right? So can we use Beggar's method over here? No. So here simply we need to create cases, right? Making sure the constraints are the constraints are used, right? So if we say that if we select 2 red apples, 1 white apple, so becomes 3, then we'll select 2 oranges, right? Oh, so sorry guys. This would be, how many red apples are there for constraint? 1. Okay. Red apples, it's 1. Let's say that we select 2 oranges. Then we select 1 white apple. So how many red apple are remaining? 2. So for selecting it 5 times. So 2 plus 1 is 3 plus 2 it's 5. So this would be red apple, right? This is okay. Now, can we select this? 2 oranges, 2 white apples, and 1 red apple? Yes, this can be also a particular case. This is case 1. This is case 2, right? Any other ways with which we can create 5 such things? So one more thing, we can't create 2 and 3, right? If this is the case, then red apples would be 0. If red apples, we need at least 1 red. Yes. So we can't go for 2 and 3, right? Okay. Is there any case remaining? Yes. The case 3 would be what? Yes, 3, 1, 1. 3 oranges, 1 white apple, and 1 red apple, right? Okay, crazy. Total how many oranges do we have? Total 8 oranges we have. Total 5 white apples we have. Total 7 red apples we have, right? So there is nothing but a simple selection problem, right? We need to select 2 oranges out of 8, which is 8C2. Now we will multiply over here, right? Because we have to simultaneously select 1 white apple and 2 red apples also. So we will multiply it over here times 5C1 times 7C2. This is case 1. Now this case is done. If there are cases, then we add, right? Because this thing would occur independently. Case 1 and case 2 occur independently, right? How many oranges are there? 8. How many white apples are there? 5. How many red? 7. Okay. So for case 2, we need to select 2 oranges out of 8. This is nothing but 8C2 times 5C2 times 7C1. Okay. This is nothing but case 2. Adding this with case 3. How many oranges are there? 8. How many white apples are there? 5. How many red apples are there? 7. Okay. So case 3 is what? Selecting 3 oranges, one white apple and one red apple, right? So just adding this up would give us the answer, right? So if we add this 8C2, this is nothing but 8 into 7 upon 2. This 5C1 would be nothing but 5 times 7C2, 7 into 6 upon 2, right? So if we solve this only, 7 4s are 28 into 5 into 2 3s are 6, 7 3s are 21 plus 8C2 just now only we calculated it as 28 times 5C2. 5C2 is what? 5 into 4 upon 2, right? Times 7C1 is nothing but 7, okay? So if we solve this, this would be nothing but 28 into 10 into 7, right? Plus 8C3, 8, 7, 6. 5 factorial got cancelled. 8 minus 3 is 5 factorial and 1 3 factorial. 3 2s are 6, right? Times 5C1 is nothing but 5 times 7. So if we solve this, 28 5s are, what is 28 5s are? 5s are 40. 5 2s are 10 and 4, it is 140. 140 times 21. So nothing but we need to do 14 times 21, right? 4, 1, 4 2s are 8, 2 1s are 2. This gives us 4, 9, 294. So this is nothing but 294 plus of 28 into 10, 280 times 7. So 28 into 7, 28 is 7, it's a 56. 10 to the 14 and 5, it's 19, 196. 28 sevens are gives 196 and this 10. Oh, so sorry. This is 1960. And the third one gives 7 8s are 56. This is 56 times 5 times 7. This is nothing but 7 5s are 35. 56 into 35. 5 6 are 30, 5 5s are 25 and 3 28, 6 3s are 18, 5 3s are 15 and 1 16, 8 1s are 8 2s are 16, 6 7 8 9. This also gives us 1960. Okay, now I think so this answer given typed over here is wrong, right? So if we solve this, this would be 1960 plus 1960 plus 294. This gives us 4, 6 plus 6, 12 and 9, 12 and 9, it's 21, right? 2, 2940. What is this 2940, guys? Oh, is that the case? I've done a mistake over here. 28 5, 28 into 5 into 21. Oh, okay. This is 2940. 28 into 5. Let me recheck. Yes. 140 into 21 gives 2940, right? Okay. So this is nothing but 2940 plus 1960 plus 1960. Okay. So this gives us 6 plus 6, 12 and 4, 16. Right. So this answer is correct. 9 3s are 3 9s are 27 and 1 28. 2 2 plus 2 4 5 6 6 8 60. Yes, this becomes the answer. Right. Everybody got? So yehi means this silly mistakes you need to avoid in the exam also. I also did a mistake over here. Ek 0 bhul gaya. But yeah, you all got the point how to solve this type of questions, right? In this question, there was only one thing. The beggars method we didn't have to use over here. यहाँ पे हमें beggars method नहीं use करना था. Why? Because the items are not identical. And beggars method is only used when the items are identical, right? All the coins needs to be distributed. All the coins are same, right? So when the items are identical, then only we use beggars method over for such questions, right? Everybody clear? Any doubts? They're all set. Great. Done. Okay. So this question was just simple PNC plus case making. Okay, this question was from this. Okay. All these topics are very important, right? The first question we solved was from just selecting the simple inclusion exclusion principle. The second question came from PNC and case making. Now let's see the third question. A company is organizing transportation for a group of 8 employees who need to be traveled from city A to city B for an official meeting. Okay. To arrange the journey, the company hires 3 cars, each of different make, making the cars distinct from one another. Okay, तीनों गाड़ियां अलग है, right? All the 3 cars are different. Due to safety and comfort regulations, each car can carry at most 3 passengers. Okay, the car can only carry 3 passengers at most. It can carry less, but at max they can carry 3, right? All the 8 employees must be transported from city A to city B. Okay, all the 8 should be transported from A to B, and every employee must be assigned to exactly one of the 3 cars, right? भाई एक बंदा 2 गाड़ी में तो नहीं जा सकता, सब अजय देवगन नहीं होता है, right? So okay, with these conditions in place, the logistics teams want to determine in how many ways the 8 employees can be distributed among the 3 distinct cars, right? So this question is nothing but distribution. This is a distribution wala question where we need to distribute 8 people among 3 cars. 8 people among 3 cars, right? Now, what is the constraint? That each car can carry at most 3 people, and there is the case that from city A to city B, all 8 members should go. So how many cases would be possible? That the first car caters 3 people, the second car caters 3 people, 6 people, 2 people remaining, the third cater 2, right? If 45 is the answer, 3 maybe, right? So 3, 3, 2 is a possible case. All the arrangement will do, right? 2, 3, 3, 10, 3, 2, 3. All the arrangement will do in the. If you guys would have seen the lecture, there is nothing but okay. Any other possible case apart from 2 and 3? Apart from 2 and 3? Apart from 2 and 3, any other case? When this car caters 4 people, no. This can cater 2 people. If this also caters 1 person, so how many are remaining? 2 and 1? 3. How many remaining? 5. So this can't be also the case. So there are no other cases apart from 2 and 3, right? So how can we do this? So here, first of all, we need to create the groups, and then we need to distribute the items among the groups, right? If you guys would have seen the lectures, this is nothing but 8 factorial upon all the distinct groups k factorials, right? 3 factorial, 3 factorial, 2 factorial. Now, these 2 are completely the same. These 2 are completely the same. So we need to divide this also with 2 factorial. Now, distributing this 3, this is nothing but number of groups, right? Now, distributing this 3, we need to multiply this by 3 factorial. This is one way which you can solve the question. This is one way which you can solve the question, right? What is the another way? Simply create 3 cases, right? 3, 3, 2, 2, 3, 3, yeah, 3, 2, 3, right? Simply do it as simple, same like hotel question. Yes, correct. So how many ways? 8 factorial by 3, 3 factorial, 3 factorial, 2 factorial. This is what? 8 factorial by 2 factorial, 3 factorial, 3 factorial. So this is nothing but this would be this, multiply by 3, right? So if we solve this, this would be equals to this, right? This would be equals to this. So if we solve this, 8 factorial by 3 factorial, 8, 7, 6, 5, 4. 1 3 factorial gone. There are 2 factorials. 2 and 2. 2 2s are 4. 7 8s are 56. 5 6 are 30. So 56 times 3. 6 3s are 18. 5 3s are 15 and 116. 1680. 1680 becomes the answer. This is using the first method. Similarly, if we solve using this 8 factorial upon 2 factorial 3 upon 8 factorial upon 2 factorial into 3 factorial into 3 factorial times 3, right? So if we solve this, what we would get is 8 7 6 5 4 1 3 factorial got cancelled. 3 2 into 2 times 3. See, we got the same result. 2 2s are 4, 5 6 are 30. 30 into 56 gives us 1680. 1680 becomes the answer to this question, right? Using both the ways. Okay. Why did we multiply by 3 factorial in the numerator in the first case, in the first method, right? So what does this give? If you would have seen the lecture, what is this? 8 factorial upon 3 factorial into 3 factorial into 2 factorial into 2 factorial. This gives nothing but the number of groups in which we can distribute 8 people 3, 3 and 2 in 3, 3, 2 ways, right? Now, this 3 factorial is nothing but to arrange, right? Arrange these groups 3, 3 and 2 like we are doing it over here. 3, 3, 2, 2, 3, 3, 3, 2, 3. This the case we are doing the thing. 3, 3, 2, 2, 3, 3, 3, 2, 3 cases से किया. Please explain this method. Okay. ये कैसे किया? देखो. 3, 3, 2, right? Total there are 8 people. How all the 3 people are same for this car? All the 3 people are same for this car. All the 2 people are same for this car. We need to arrange 8 people. Arranging 8 people gives 8 factorial. Arranging 3 same people, 3 same people and 2 same people. We just need to divide it by 3 factorial into 2 factorial, right? Similarly for 2, 3, 3, this is also same. 2 factorial, 3 factorial, 3 factorial. Similarly for 3, 2, 3, this is also same. 8 factorial, 2 factorial, 3 factorial, 3 factorial. All the cases add, all the things are same. So simply we did 8 factorial upon 3 factorial into 3 factorial into 2 factorial times 3. Right? Right? Done. Okay. No doubts. This gives 1680 as the answer. भैया डिनोमिनेटर कौन सा? दिस वन. डिनोमिनेटर में एक 2 फैक्टोरियल आएगा. हाँ, एक ही तो 2 फैक्टोरियल है. आएगा because 3 factorial and 3 factorial are same. I mean one. अच्छा, you are saying okay. So you are mixing the 2 methods, right? So Dhruv, the thing which you are saying is regarding this method, right? कि एक और 2 factorial तब हम मल्टीप्लाई करते हैं जब हम पहले नंबर ऑफ ग्रुप्स निकालते हैं और फिर उस ग्रुप्स को अरेंज करते हैं, राइट? बट ये जो अभी हमने किया लास्ट में, दिस इज अनदर मेथड. दिस इज सिंपली केस सॉल्विंग. दिस इज केस 1, दिस इज केस 2 एंड दिस इज केस 3. फिर ये केस 1 का हमने आंसर निकाला, केस 2 का आंसर निकाला, केस 3 का आंसर निकाला एंड वी सॉल्व्ड इट, राइट? सो first of all, there are two different methods, but both the methods gives the same answer, of course, but the approaches of both the methods are different, right? Means you can use any one method जो आपको सही लगे. If you are good with case making, you can go with case. If you would have seen the lectures, it is very much same कि if you would कि वहां पे हमने distribution हमने सिखाया था कि how did we distribute. In the lecture we have also gone through the proof कि why do we multiply this by 2 factor and all the other ways. Go and see the lecture once more, and I think so this was covered in lecture 2 of PNC, right? It was the most important lecture. So go through those lectures and you would get to know about this method, right? And for all the people who are watching this video, so what I'm talking about is the courses which we run for the light batch of Delta Education. So if you want to also enroll for the same, you can go to the website www.thedelta.co.in. You can check for the light course, and you would be also be available. Means you can also watch to the courses which are available live, right? Okay. So this was all about PNC. 3 important questions. The first question was from inclusion exclusion principle. Second question was from what? Second question was simple case making, and third question was from distributing things. So distribution. So 3 important topics, 3 important questions, very much similar to your scalar and set. Coming to probability. Okay, probability. Now let's read the question. During the mathematics enrichment session, Acha, let's do one thing. Do we have time? This would take another 30 minutes. Do we have time? Okay, we would not be having. If you guys are okay, if you want to solve the questions first on your own, then you can do, but just leave it. Means then the session would be stretched for a long. But yeah, okay, I'll just do it. You means simultaneously you can solve and give the answers in the chat, right? Okay, let's see. During a mathematics enrichment session, 2 students are participating in number-based experiment. As the part of the activity, they independently and randomly choose 2 integers m and n from the set of whole numbers. Each number in this range is equally likely to be selected, and the choices of m does not affect the choice of n. Okay. So randomly, sorry guys, randomly we are choosing 2 numbers from 1 to 100. So selecting the number m, there are 100 ways. For selecting the number of n, there are also 100 ways, right? For getting number of items in a set, so there is nothing but 100 minus 1 plus 1. So 99 plus 1, this gives us 100. So this set contains 100 items, right? Okay. sorry. After selecting these 2 numbers, the students use them to construct a new number by raising 9 to each of the chosen powers and adding the results together, forming the expression 9 to the power m plus 9 to the power n. Okay. Curious about the divisibility properties of such expressions, the students decide to investigate when the number formed in this way is divisible by 5. What is the probability that the number this is divisible by 5? Okay, great question, right? I think so. Similar question we solved in one of the lectures also. I think so. There were just this thing 7 to the power m plus 7 to the power n, right? So here there is nothing but 9 to the power m plus 9 to the power n. Okay, right? So approach. How to solve? So how to solve? First thing, what are the total or probability? What are the total number of ways of selecting 2 numbers? This is nothing but 100 into 100. This gives us 10,000 ways. Okay. Now selecting a number 9 to the power m plus 9 to the power n such that modulus it with 5 gives 0 as the remainder, right? So this number, ka unit digit, if it is 0 or 5, whatever be the digits ahead of it can be so if ye addition karke the number that we get, and if that number has a unit digit of 0 or 5, then we can say that this number is divisible by 5, right? Means either should be odd and even. What either, Harsh, right? So we'll see. Okay, this is the thing. Great. Okay. Now how would I find, right? there is something regarding 9k powers, right? कि कुछ तो 9k power से we need to do, right? So what we'll do, let's see a pattern, right? 9 की power 1 is what? 9, okay. 9 की power 2 is what? 81, okay. 9 की power 3 is what? Nothing but the unit digit would again be 9. 9. For the power 2, the unit digit was 1. For the power 1, the unit digit was 9. For the power 3, the unit digit was 9. For power 4, again, the unit digit would be 1. 9 9 is 81, 1, right? And this would repeat itself. So the cyclicity of 9 is nothing but 2. Okay, this question is mixed with number theory. What is cyclicity? Cyclicity is nothing but the number of times after which the unit digit gets repeated for after some powers, right? So for 9, the cyclicity is 2. So we can say that 9 to the power 1, 9 to the power 3, 9 to the power 5, 9 to the power 7, and so on up to 9 to the power 99. This would give us as 9 as unit digit, and for all those numbers as 9 to the power 2, 9 to the power 4, 9 to the power 6, 9 to the power 8, up to 9 to the power 100 would give us 1 as the unit digit. Okay. Okay. Now, we need to sum two numbers. We need to sum two 9 key powers and get 0 or 5 as a unit digit. Now we only have these two possible things, right? 9 plus 1 gives 10. 10 has a 0. Okay. So if we say that 9 to the power m, here m contains odd numbers. 9 to the power n, m contains even numbers. How many such ways are possible? So there are total 100 numbers here are divided into two groups. So 50. There are 50 numbers in each group, right? So we are saying that we are selecting 9 to the power m in such a way that the unit digit is 9. We are selecting 9 to the power n number in such a way that unit digit for the same is what? 1. How we can select this two? There are 50 ways over here, 50 ways over here. So how many ways we can select both of them, m and n? This is what? 50 into 50, right? This is nothing but 2500. Okay. We can also do one thing, right? We can also do one thing, that 9 to the power m, we are selecting 9 to the power m in such a way that its unit digit is, here we did it as 9, here we did it as 1. Similarly, for 9 to the power n, we do it for as 9. This is also a possible case, right? Here also contains 50, here also contains 50. So 50 times 50 plus 50 times 50 upon 10,000. This is what? 2500 plus 2500 upon 10,000. This gives us 5,000 upon 10,000. This is nothing but half, and half becomes the answer. Yes, everybody got this question? How to solve this? Any doubts? Can we move forward? I think so, yes. We have solved this question in the class, so I think so everybody are good to go. But yeah, for all the other people, you can clearly get a question of probability merged with either number theory, either set theory, either PNC, right? Probability question in itself are very easy, so expect a question mixed, right? So this question was of what? Probability plus number theory. Okay, an important type of question, right? Okay, let's move forward to the next question. Okay. By examining the chest X-ray, the probability that TB is detected when a person is actually suffering is 0.99. Okay. Now here there is something of conditional probability. Okay, what is this saying us? That TB is detected when a person is actually suffering, right? Matlab, test detected and the person actually has TB is what? 0.99. Okay. The probability of a healthy person diagnosed to have TB, right? Probability of a healthy person to be diagnosed, the person is healthy but he has got TB, right? Is what? 0.001. Okay. In a certain city, 1 in 1,000 people suffers from TB. Okay. So what this have given? Probability that a person has a TB is what? 1 in 1,000. 1 upon 1,000. This is the probability, right? So this is what? 0.001. So we can say that person not having TB is what? 1 minus 0.001, this is nothing but 0.999, right? Okay. Now, a person is selected at random and is diagnosed to have TB. Okay. It is said that from 1,000 people, we selected one people and the person was the test we did and we got a positive test that he is having TB, right? What is the probability that he actually has TB? Okay, there can be two possible cases, that a person is healthy and the healthy person has got a positive TB, a positive or is having a TB, right? Another case would be what? Person is unhealthy, matlab person is actually having TB and the test actually detected positive for the person having TB. Matlab ki person is unhealthy, the person is unhealthy, right? And the unhealthy person detected a positive answer, right? And there is a condition. So this is what? Probability that a person is actually, person is detected positive. Person is diagnosed with positive TB, right? There is nothing but this. What we need to find is nothing but key. The person is actually having TB, right? This is what? Person, if the person is unhealthy, times probability ki positive aayega test if the person is unhealthy, whole upon person is healthy and the healthy person gives a positive test plus a person is unhealthy and the unhealthy person gives a positive test, right? There is nothing, this is the thing we need to find it out, right? This is the question of Bayes theorem. This is a Bayes theorem question. Okay, let's substitute. What is the probability that a person is healthy? A person is healthy, matlab person does not have TB. So this is what? 0.999, right? A person does not having TB is nothing but 0.999. Okay. Times. A healthy person ka test gives a positive result. This they have given a healthy person, the person is healthy, but the report is coming out to be positive, right? This is what? 0.001 times 0.001 plus. What is the probability that person is actually unhealthy? What does this mean? That person actually has TB. What is this probability that a person actually has TB? It is 0.001 times the probability that the person is unhealthy and is getting in positive, right? That TB is detected when the person is actually suffering. Means there is positive, but the person is unhealthy and there is the positive detection, right? So this is what? 0.99. So times 0.99. So upar bhi, this is the same thing. Just solving this gives us the answer. This gives us the answer as this. But if we solve this, this is what? 0.00099, right? Whole upon 3 plus 3, 6. Okay. 0.00999 plus 0.00099 right? Right? So this is what 99 into 10 raised to the power minus 5 whole upon 999 into 10 raised to the power minus 6 plus 99 into 10 raised to the power minus 5. If we want to get the 10 raised to the power minus, okay, so if we multiply only this by a 10 and divide this by a 10, right? So 99 into 10 raised to the power minus 5, we need to create denominator as minus 5, right? So hence we did this. So this is what 10 raised to the power minus 6 into 10 gives 10 raised to the power minus 5. So this is what 99.9 into 10 raised to the power minus 5 plus 99 into 10 raised to the power minus 5. Taking 10 raised to the power 5 as common, and then the numerator and denominator, the 10 raised to the power minus 5 would be cancelled. This would give us 99.99 plus 99. So 99.9 plus 99. This gives us 9 2s are 18, 9 2s are 18 and 1 19, 198.9. So the answer is 99 upon 198.9. So this is nothing but 990 upon 1989. So see, I can see that this is 11. Okay, so 9 plus 1, 10. 10 plus 8 is 18. 18 plus 9 is 27. Okay, this is also divisible by 9. This is also divisible by 9. Okay, 9 into 110, right? 9 ones are 9. 9 2s are 18 and 119. 9 2s are 18. 9 ones are 9, right? This gives us 110 upon 221. This becomes the answer. 110 upon 221. And if we solve this in scalar, they could either ask as x plus y, or they could ask in decimal also. So if they are asking in decimal, round off up to 2 decimal places, right? Round off up to 2 decimal places. Now, as the calculator is allowed in NSET also, I'll also use a calculator. So this is what 110 divided by 221. This gives us 0.4977, rounding off up to 2 decimal places, right? So okay, this is greater than 5. So here we add plus 1. So this would create what? If we are adding plus 1 and this is becoming a 0, we add plus 1 over here also. So this would be nothing but 0.50 as the answer if we round off up to 2 decimal places. If we round off up to 3 decimal places, then the answer would have been 0.498. Okay. So this is something regarding to round off. Again, checks. Yes, this is something regarded to round off. Yeah, if they are asking up to 2 decimal places, then the answer would be 0.50, right? Why? Because the answer is 497. This number is greater than 5. So we need to add 1 over here. Now, 9 plus 1 gives 10, right? Which is greater than 9. So we need to add plus 1 also over here. So rounding off gives 0.50 and not 0.49, right? Because if it is greater than 9, we need to add plus 1. So the answer, if round up to 2 decimal places, then it would have been 0.5. If 3 decimal places, then it would have been 0.498. Good? Yeah. Any doubts in this question? Great. So talking about this question was of Bayes theorem, right? Bayes theorem. This is an important topic, Bayes theorem. Expect one question tomorrow, of course, not tomorrow. When is your exam? On 11. There would be one question in your paper of Bayes theorem for sure. For sure. Right? One question of Bayes theorem would be there. Okay. Going forward to the next question. Okay. During a classroom activity on probability, A bag is placed on a table containing 6 white balls and 4 black balls. Okay, so there is a bag with 6 white balls and 4 black balls. Okay, bag. Great. All identical in shape and size for their color. To introduce an element of randomness, a student first rolls a pair 6-sided die once. Okay. Okay, so there is someone who is rolling a die. Okay. The number that appears on the die determines the next step of experiment. Based on the outcome of the roll, the student then draws that many balls at random from the bag. Okay, all in one go without looking into the bag beforehand. Okay, so what is this saying? That first he will roll a die, the number which appears on the die, that many balls he take out from the bag. Okay. After the balls are drawn, the student checks their colors. Okay. What is the probability that all the balls drawn in this experiment are white? Okay, great question, right? You guys try to solve this question, right? Try to solve this question. If we solve this, if we go and solve this question, okay. So first step is what? First of all, make sure keep in probability questions. You are always writing a probability of doing any task, right? You are rolling a die, right? You are rolling a die. The probability of getting any number is what? 1 by 6. Now, you can get either 1, 2, 3, 4, 5 or 6, right? And what is this saying? That all the balls which you draw are white, right? All the balls are white. So, if the number came out to be 1, so all the balls should be white. So, how many ways? 61 are the total number of ways in which we can select one white ball out of 6. What would be the total? 10 right? Okay. This is for if one came, and all white. Now, the number 2 came, and we are selecting all white, right? So, this is what? 62 whole upon 10C2, right? 2 came plus all white. Similarly, 3 came and all white. 4 came and all white. 5 came, this is 6, 1 by 6, 1 by 6, 1 by 6, 1 by 6. 5 came and all white plus 6 came and all white. Okay, so we just need to solve this. Everybody got this? Why we did this? Yes, any doubts over here? Now, further there is just the question of solution, right? So, taking 1 by 6 common gives us 61 upon 10C1 plus 6C2 upon 10C2 plus 6C3 upon 10C3 plus 6C4 upon 10C4 plus 6C5 upon 10C5 plus 6C6 upon 10C6. Is this the addition theorem? Yes, right? Why we added over here? Because the die is rolled only once, right? So we can't simultaneously get either 1 or 2, right? We can independently get 1 or 2, but simultaneously we can't get 1 or 2, and hence we are adding, right? So yes, this is the principle of counting, and in those principle of addition. So I'll just solve this. Okay. A lengthy is there any way in which we can reduce this? By any chance we can? No. We have to solve this. There are no properties. Okay. We have to solve this. Okay. 6C1 is nothing but 6. 10C1 is nothing but 10. Okay. 6C2. Answer 0.2. Let's check answer. So, yeah, answer would be 0.2. Yes, correct. Answer is 0.2. Let's solve 6 into 5. 4 factorial got cancelled upon 2. 10 into 9 upon 2 plus 6, 5, 4. 1 3 factorial got cancelled, another 3 factorial. 10, 9, 8. 7 factorial got cancelled, 3 factorial plus 6C4 is nothing but 6C2, and 6C2 was this. 10C4 is what? 10, 9, 8, 7, 4, 3, 2. 6C5 is 6 and 10C5, 10C5, 10, 9, 8, 7, 6. 1, 5 factorial got cancelled, 5, 4, 3, 2. Okay, first let me solve this much. 2, 3s are 6, 2, 5s are 10. So this is 6 by 10, 6 by 10 plus 5 3s are 15 by 5 9s are 45. Plus 3 2s are 6, 3 3s are 9, 2 4s are 8, 4 3s are 12 into 10. So 125 4s are 20, whole upon 4 is 120. Plus, solving this, 2 3s are 6, 15. This would be 4 3 2. 4 2s are 8. 3 3s are 9, 7 3s are 21. So this is 5 3s are 15 upon 210 plus 6 upon 5 2s are 10, 3 3s are 9, 4 2s are 8, 3 2s are 6. 6 into 6 7s are 42. 6 2s are 12, 24, 252. So this is 6 upon 252. Okay. Oh my God. 1 by 6 whole into, okay, what is remaining? 6C6 upon 10C6. First let me do this. 6C6 upon 10C6. This is nothing but 6 factorial upon 0 factorial into 6 factorial. This is nothing but 1. 1 upon 10C6 is nothing but equals to 10C4. This is this. 7 3s are 21. 210. This is 210 upon 210. Okay. So the answer becomes 1 by 6 whole into 6 by 10 plus 15 by 45 plus 20 by 120 plus 15 by 210 plus 6 by 252 plus 1 by 210. Okay. Solving this, 15 3s are 45, 2 6 are 12, 3 5s are 15, 3 7s are 5, 14 5s are 70, 6, 2 3s are 6, 2 5s are 10. This is 6. 6 4s are 24 and 1 12. 6 2s are 12. So yeah. So this is nothing but 1 by 6 whole into 3 by 5 plus 1 by 3 plus 1 by 6 plus 1 by 14 plus 1 by 42 plus 1 by 210. Okay. Solving this, 5 3s are 5 are 3 3s are 9 plus 5 14. 15 upon 5 3 are 15. 6 and 14. चलो 6 and 14. 6 and 14 का एलसीएम क्या होता है गाइस? 6 और 14 का 2 3 2 7 3 and 7 7 3 21 2 42. Okay, so this is into 7. This is into 3. 7 plus 3 is 10. 14 3 is 42. Okay. Now this one 42. 5 for the 20. Okay, this is into 5. This is 5 plus 1, 6 upon 210. So this becomes 1 by 6 whole into 14 upon 15 plus 10 by 42 plus 6 by 2, 10. Again, LCM of 15 and 42. Achha, 42 paisa was 210. So this is 1 by 6, 14 upon 15. 5 tens are 50 plus 6, 56 upon 210, right? Okay. So 56 upon 210, 56 upon 210. So this is 2 2s are 4 and 1 5, 2 8s are 16, 2105. 28 and 105. 5 8s are 40, 8 is a 6 is a 48. Is there anything else? I think so, nothing. So this is 14 by 15 into 1 by 6 plus 1 by 6 into 28 by 105. So this can be done. 2 1s are 2, 2 4s are 8, 2 3s are 6. अच्छा चलो 1 by 6 रहने दो. 15 और 2 10 का एलसीएम ही ले लेते हैं, अच्छे से होएगा. 15 और 2 10 का एलसीएम लेते हैं तो क्या आएगा? 15 और 2 10. क्या 15 से 2 10 बन सकता है? 15 अपॉन 2 10 क्या होता था? 5 3 5 4 20, 1 5 2 10. Oh yes, 3 1 3, 3 4 12. Okay, 15 into 4 is 210. 15 into 14 is 210. So sorry, 15 into 14. So this is 1 by 6 whole into 14 का square is 296, right? 14 का square 296 होता था. I forgot. 4 4s are 16, 4 1s are 4 and 1 5, 4 1s are 4. Oh, this is 196. 196 plus 56 whole upon 210. 196 plus 56, 6 plus 6, 12. 9 plus 15, 252. 252 upon 210 into 6. अच्छा, बहुत बढ़िया. क्या 6 4s are 24, 125, 6 2s are 12. 42 upon 210, 42 into 5s are 42, 5 2s are 10, 5s are into 42. So this 42 and answer came out to be 1 by 5 answer. ठीक है, बहुत अच्छा कैलकुलेशन था इस क्वेश्चन में, बट हमने थोड़ा सा सबर रखना है. अच्छा, तुम लोगों के पास तो कैलकुलेटर है. हाँ, कैलकुलेटर पे भी इस पे सही से करना, वो ब्रैकेट वैकेट सही से डालना. Try to means use the calculator also correctly. But if you don't have the calculator, you just have to be patient and solve this, right? So the answer to this question becomes 1 by 5, and we are trying to solve it in decimal. This is nothing but 0.2, right? 0.20. Okay. So this question was of simple probability included PNC, right? Probability है PNC. This question was of Bayes theorem, and the first question was of probability with number theory. Okay, right? So this is all from my side, guys. This is all from my side. So we solved 3 PNC questions, 3 probability questions, all very important. All the questions very much similar to scalar and set. Now I would request Saurashish to continue forward. But before that, if you guys have any doubts regarding these two topics or regarding any of the questions currently, then you can ask me. Okay. While using scientific calculator, won't the AI proctoring consider it as a phone? So don't use a scientific calculator, guys. Then means yes, very correct point. Very correct point. Don't use a scientific calculator. Then use a normal calculator. More same question of PNC. More same questions. Go and check the practice sheet. Right? Can I give exam in other screen than the screen in which my webcam is there? Try to give you a mock test on the Scalar platform. If they are allowing that thing, then yes. But yeah, all sort of those questions you can ask the Scalar team. But as far as I know, try to give a mock test, the mock which they have given. Try to do that, and you will find out. But they will find it. Okay. So yeah, okay. Let's not waste time. Krishna, are you continuing or Sorashish?
Yeah, I'll continue LR.
Okay.
As maths is very heavy, so we want to like give students LR as well as flavor of
great,
LR.
Great. Okay. So guys, thank you for giving your time. I'll just leave now. Krishna would continue for LR, and then Sorashish would come and solve other questions of other 4 questions, I think. So yeah, 4 questions are remaining, and Sorashish would do it. On to Krishna.
Fine. I'm sharing my screen. Is my screen visible, guys? Just let me know in chat. Okay, got it. Fine. So as you saw that maths takes a lot of time, like, so that's we need to do LR quickly so that we can save time for maths. So in this session, just like treat it as your real exam. Just try to solve with me as quick as possible and test your speed. So let's quickly solve this, and let me know your solutions as well in the chat. I'm seeing the chat. Let's start with first question. Read and start solving. In the address, in the Adarsh Nagar Housing Society, the overhead water tank is empty. 2 watchmen, Ramesh and Suresh, manage the filling using 2 motors, M1 and M2, and 1 drainage valve D. Okay. Means drainage valve is taking water out, and M1 and M2 motors are helping to fill the water tank. M1 can fill the water in 10 hours, M2 in 15 hours, and D can empty it in 12 hours. Okay. They work in an alternating 1 hour shift. Okay. So means Ramesh and Suresh are working in alternating hour shift, starting with Ramesh at 8 a.m. So we have given the example like Ramesh shift is 1, 3, 5, Suresh after that. Okay, so it's alternating. In Ramesh's shift, he runs motor M1 and M2 at 100% capacity, but keeps drainage valve open. Okay. And in Suresh, it's like drainage valve is closed, but motors are running at 60% capacity. Okay. At what time will the tank be completely full for the first time? Okay. Fine. So let's start solving this question. Yep. Pen is working. Got it. So this is like time and work kind of question where if you have seen lectures of delta, we have discussed about the formula efficiency equals to work done by time, right? Work done by time. So here, let's see, we need to calculate efficiencies of M1, M2 and drainage valve so that we can calculate other stuff. Before that, for making our question solving easy, we need to assume work done, right? And in lectures, there are two ways. Either we assume it as 1, which is also one way of solving question. And one other way is also to take LCM. So we have time of M1. M1 takes 10 hours, M2 takes 15 hours, and D takes 12 hours to empty. So if we take LCM of these three values, what's that? Tell me in chat. 10, 15, and 12. Yep. Okay. 60. Yeah. Correct. Harsh, John, Dhruv, fast. Okay. So let's consider the tank capacity as 60 units. So which will be easier for us for mathematical calculations. So our tank capacity is 60 unit. Now tell me the efficiencies of M1, M2, M3 with this formula. M1 efficiency is 60 by 10. It's like 5. And M1 is filling the tank, so it's plus 5. Similarly, M2 is 60 by 15 hours. Work done is 60, time is 15. So it's 15 hours. So it's plus 4 because it's also filling the tank. Then we have valve D. Work done is 60 and time taken is 12 hours. But this is taking out water out of the tank. So it's like negative efficiency, minus 5. Fine. So we got the efficiencies of M1, M2, and M3. Now we just need to follow the question like Ramesh runs motor M1 and M2 at 100% capacity but keeps drainage valve open. So if we do that, so in Ramesh's turn, M1 and M2 runs on 100% capacity and drainage valve is also open. So like it's negative D, right? Wait, did I make a mistake? Oh yeah, M1 will be 6, sorry. Calculation mistakes. 60 by 10 is plus 6. Thank you, Deep. So fine, M1 plus M2 is like 6 plus, what's M2 for? M2 is 4. And then we have D. This is efficiency of D, that is 5. So the final efficiency of all three working together is 5 plus 5. 10 minus 5 plus 5. So in Ramesh's turn, 5 unit of water is filled in the tank per hour. This is the efficiency when Ramesh shift is there. And when Suresh shift is there, it's like Suresh in Suresh shift, M1 and M2 works at 60% capacity. Okay. And drainage valve is closed, so we'll not talk about that. So M1 and M2 is 10 and at 60% capacity. So 60%. So what is the capacity of this? Just 6 units per hour. Right? So we got efficiency in the shift of Ramesh and in the shift of Suresh. Now they will be doing work in alternating way. First Ramesh, then Suresh, then Ramesh, Suresh, like this. So let's calculate the efficiency of one cycle, RNS. So it's like 5 plus 6, 5 plus 6 equals to 11 unit. 11 unit is the combined efficiency of the cycle. So in 2 hours, it will be 11 unit. No, Harsh, that's not right answer. Keep calculating. So the combined efficiency of a cycle is 11. Now, how many cycles we'll need, right? In one cycle, like in 2 hours, 11 unit of water is filled in a tank whose capacity is 60 units. So how much cycles we need? Like And so if I multiply it by five cycles, so it's 55 units of water will be filled in 5 cycles. 5 cycles means 10 hours, right? Still 5 unit of water is left. So after the fifth cycle, again the turn of Ramesh will be there, right? So Ramesh efficiency is +5. So 55 plus 5 is 60. So 10 hours in this 55 cycles plus 1 hour in this cycle, so 11 hours. So 11 hours from 8 a.m. 11 hours from 8 a.m. So it's like 7 p.m. evening. Did you guys understand? Jahan, Harsh. Okay. So see, Dhruv, Ramesh and Suresh work in shift in alternating hours, right? So in the shift of Ramesh, as we calculated, 5 units of water is filled in the water tank because can you say this M1 plus M2 minus D? M1 and M2 is working and D valve is also open, which is taking water out. So the combined efficiency is 6 plus 4 minus 5, which is plus 5 units of water is getting filled in the water tank during the shift of Ramesh, right? And it's also the Ramesh shift is also lasts for 1 hour, right? So just 5 units of water is getting filled. Plus in the turn of Suresh, it's like 6 units of water is getting filled in the water tank. No, 11 hour. No, we are starting at 8 a.m. in the morning, right? And if you consider like after 12 hours, it will be 8 p.m., right? But currently, our work is just 11 hours. So 11 hours from 8 a.m. is 7 p.m., isn't it? Jahan, let's move on to next and quickly solve this as we don't have much time. Yep. So hope you have read the question. Kabir starts with his house from his house at point A at 7 a.m. He runs 40 meter towards east. Okay, so with direction questions, we have seen that we make this diagram for easy understanding. North, south, east, west. Quickly solve, and if you get the answer, just let me know in chat. Kabir starts from 10 from his house at point A. Okay, this is point A at 7 a.m. Okay, this is also very important. He runs 40 meters towards east. So this is east, 40 meters. Then east. Takes a left turn and turns 20 meters, right? So he's facing east and then he takes a left turn. So left turn is towards north. So it's toward north. And he runs 20 meters towards north. Then he turns 135 degrees anti-clockwise. Okay, so what's 135 degrees from here? Then he turns 135 degrees anti-clockwise. So this is the anti-clockwise direction. He's facing towards north. This is 90 degree and like 90 plus 45 is 135. So 45 is like exactly the half of this 90. So this is 135 degrees anti-clockwise. Right. So now he's facing this direction, which is southwest. And he runs 20 root 2 meters. 20 root 2. Right. And then finally he turns such that his shadow falls on his left and runs 50 meters to reach the juice shop. Okay. So now this is a very important part. Like they are talking about shadow. So he's currently here. He's facing this direction. And also from the Pythagoras theorem, you might have understood like this is 20 meter. This hypotenuse is 2 root 20 root 2 means this should be 20, right? So by Pythagoras formula, if someone don't know, they can check that this will be 20 root 2. So, and this remaining part will be 20. So currently he is at this position. And now they're telling that he turns such a way that his shadow falls left. And in lectures also we discussed that about shadow questions. So the time is 7 a.m. in the morning, means sun will be here, somewhere here, and shadow will be on this west direction, right? West direction. So he turns in such a way that his shadow falls left, right? So if shadow is in left, means his left is west. His left is west. Currently, he's so when where should he face for him to have his shadow on left? So he should face north. Then his shadow will be on the west direction, right? Because sun is here. So he should face north, and then he runs 15 meters. So in this direction, he runs 15 meters. So here is the juice shop, and this is the point B, and this is the point A. Anyone got the answer? So we need to find out the shortest distance between A and B. And in which direction is B with respect to A? Okay. So with respect to A, B is in northeast direction. And how much is this distance? Yep. Okay, I'm getting answers. So again, like we have to use Pythagoras 15 and this is 20. So 15 square plus 20 square plus 15 square, it's like 400 plus how much? 225, it's like 625. And oh, sorry. And the root of this is 25. So correct, 25 meters is the hypotenuse and the direction is northeast. Yep. Fine. Correct, Harsh, Deep. Fine, let's move on to next question. Quickly solve this. 8 delegates P, Q, R, S, T, U, V, and W are attending a roundtable conference facing the center. Okay. So, like, it's kind of a roundtable conference where everyone is facing center. Right. So let's start by placing one by one. So S sits third to the left of P. Left of P. So let's consider P sitting here. S is third. Left is this direction. Left is this direction. So third. So first position, second position, third position. S sits here, third of P. Then Q sits second to the right of S. Okay. Q sits second to the right of S. Okay, so S is here, his right is here, and Q sits second. So Q's place will be here, right? Then U is not an immediate neighbor of either S or P. Okay, so Q will not sit here. U will not be here or anywhere here. Got it? Then W sits exactly between V and P. So P is here. We don't know V, but by this statement we can know that W will be here and V will be here, as W sits exactly between P and V. And T sits to the immediate right of U. T sits to the immediate right of U. So immediate right of U, we don't know where U sits. But U is not a neighbor of S and P, so U can't be here. You can't be here. So let's make U sit here. And then T is immediately right and U is facing here. So his right is in this direction. So T is here. T is here. And what's remaining? P, Q, R. R is remaining. So R will be here. This is the only place left. So I think we have arranged everything. P, Q, R, S, T, U, V, W. Got it. And then we need to solve who is sitting at the immediate left of person, who is sitting at the immediate left of the person who is sitting opposite to R. Okay, so first, who is sitting opposite to R? V. V is sitting opposite to R. Three people here, three people here. This is V is exactly opposite. And then who is sitting immediate left? So V is facing inside. So left of V is this direction, W, this side. This is left of V. So W is the answer. Hope you guys understood this as well. Can we move to next question? Yep, okay. I can't see your reactions if you're doing reactions. I can see the messages in the chat. Okay, let's move on to next. So there are total 10 questions, so we are currently on 4th. But I think LR questions will be quick. It will not take much time like maths. So it's 11 right now. We'll be done in next maybe less than 30 minutes. I'm hoping that. So let's quickly solve this. My watch, which gains, okay, which gains uniformly. Okay, it gains uniformly in 2 minutes, is 2 minutes behind at noon on Sunday. Okay. So on 12 noon on Sunday, the watch is 2 minutes behind and is 4 minutes 48 seconds ahead at 2 p.m. on the following Sunday, means on the next Sunday, 2 p.m. The watch is 4 minutes 48 seconds ahead, right? So in this whole span, watch is gaining uniformly. So how much time watch gain ultimately? So here it was 2 minutes behind, then maybe it went to the correct timing somewhere, and then it also started gaining time, and it reached like it was 4 minutes 48 seconds ahead. So total in this time span, it gained around 6 minutes 48 seconds of time, right? 6 minutes is gained, and yeah, we are asking like when was it correct? Sorry, yeah. So it was earlier, it was behind. Then maybe there was some point of time during this period where it was correct, and then again it increased the speed, and it's now ahead of the time. So, and it's increasing uniformly as well. So we need to calculate at what time exactly the clock was clock was showing the correct timing. So if the gain is the 6 minutes 48 seconds, so let's convert it into seconds. 6 into 60. How much is this? 360 plus 48. That's like 408 seconds. 408 seconds the watch gained in this time. And let's calculate this time as well. It's like 12 noon Sunday to next Sunday 2 p.m. So 12 noon Sunday to next Sunday 12 noon is like 7 complete days, right? 7 into 24, and then plus 2 extra hours of this 2 p.m. So let's quickly calculate this. It is 4 minutes 48 seconds. What Harsh you're talking about? It was ahead 4 minutes 48 seconds at 2 p.m. Yeah, 4 minutes 48 seconds. It was ahead at 2 p.m. of next Sunday. They observed this behavior of the watch. and at 12 noon on previous Sunday, it was 2 minutes behind. Oh, yeah. So this 6 minute is the total gain from 12 noon first Sunday to the next Sunday. How much the clock gained? It was behind here, 2 minute behind, and then it's gain at this point it gained 4 minutes. So first it covered the 2 minute of loss it had earlier. It reached the correct timing position, and then it gained time as well, and it reached 4 minute ahead. So it's like 2 minutes plus 4 minute 48 second. So that's why it's 6 minute 48 second total time the watch gained in this time period. Oh, got it. Okay, understood. Hope you understood. Fine. So the watch gained 408 seconds in this many hours. How much? Let's calculate. 7 into 48. Sorry, 7 into 24 hours plus 2 hours. How much is that? 168 hours plus 2 hours. It's 170 hours. 170 hours is the timing from Sunday 12 noon to next Sunday 2 p.m. 170 hours. So it's like simple concept, like it's gaining 408 seconds in 170 hours, right? So we need to calculate when the watch was showing correct time. So for watch to show correct time, how much time the watch needs to gain? The watch was 2 minutes behind. If the watch gain the extra 2 minute time, it will reach to the correct timing position, right? So we just need to calculate how much time this watch takes to gain 2 minutes to reach the actual timing. So what's two minutes in seconds is like 120 seconds. So we just need to in 170 hours watch gain 408 seconds. In how many hours the watch will gain 120 seconds? Just like cross multiplication. If anyone got the answer, they can share. So we need to convert this. We can just get x and then let's try. So if we cancel out, it will be something 84 into 30 by 51, and ultimately 51 hours. So it needs 51 hours to gain 120 seconds, and 51 hours will be like 48 hours means 2 days, like 24 into 2 days, and then extra 3 hours, right? 51 extra 3 hours. So it's like Sunday 12 p.m. to Monday. Okay, is there any calculation mistake? Let me check quickly. 170 into 120 divided by 408. Oh, okay, sorry. 50. So how much it takes? Like 20. Okay, so 50 hours total. 48 hours mean 2 complete days and 2 hours extra. So it will be like Sunday to till Monday, Tuesday 12 p.m. plus 2 hours, like Tuesday 2 p.m. Yeah, correct, Jahan. Tuesday 2 p.m. Let's quickly move to next question. Okay, so this is coding decoding. Okay, so we have duration. Fine. So duration can be written as BSVEOPJU. So first let's check what is the flow. Is there any relation 1 by 1? D is A, B, C, D. D is at 4, 4. D is at 2. Then U, no, here S is behind. So here it's like -2. And then Q, R, S, T, U. So here it's -2. Here it's just -1. Oh, sorry. It's A, B, C, D. Oh, sorry. And then Q, R, S, T, U. Okay, got it. So here we have any relation going on. One gap of 1 and then S and then gap of 1. Okay. And then R and S, is there any relation? No, there is a lot of gap here. So it's not following 1 by 1 relation. And then we can check like diagonal relation as well. D and U, N and B. But here also I don't see any, just a second. Oops. Okay, let's start. Someone was knocking my door. Sorry. Okay, so fine. So diagonally also it's not working. So let's try half diagonal. I'm just showing you the ways you can try out with any word you get. So here, I think like, yeah, someone has written the answer. So is there a relation here? D and E. A, B, C, D, E. Okay. So this is like just next word. And then A and B is the next word. T and U, U, V, R, S. So this is like just diagonally plus 1. You have to do plus 1. S, T, U, N, O, I, J. So it's just plus 1. So for forecast, F, O, R, E, C, A, S, T. So here we just like for F, we can do G, right? E, F, O, what's for O? O, P, R, S, and then C, D. For S, what's the, for T, T, U. For S, what's that? For S, it's T, and for A, it's V. Yeah. And Harsh has the correct answer. Hope others also understood. Let's verify. F, S, P, G, U, T, B, D. Yep. Fine. Let's solve the next question. Missing number in the series. Fine. I'll start solving. You can share your answer if you know. So let's also see the relation here. 4 and then 9. So how much is that? 4. Is it double? No, but it's double plus 1. Okay, let's see the relation here. It's something related to double. Then 9, is it 9 into 2? 18. No, this is not double. But is it triple? 9 into 3, 27. So it's 1 less than triple. And this is 1 more than double. So let's check this. 26 into, this was difference of multiplied by 2, this was multiplied by 3. Let's try 4. 4, 6 are 24, 8, 9, 10. So 104 and it's 105, so it's like plus 1. So now we can see the pattern here. In 4 and 9, it's multiplied by 2 plus 1. Here, it's multiplied by 2. Oh, sorry, multiplied by 3 minus 1. Here, it's multiplied by 4 plus 1. So it's like plus minus. So for this case, it will be 105 multiplied by 5 minus 1, right? And for this case, it will be 524 into 6 plus 1. So what should be the answer? Let's check. I got the answer from Harsh, 3145. Yep, 3145. Let's move on to next question quickly. Family, blood relations. Again, an easy question. A family of 6 members, A, B, C, D, E, F. There are 2 married couples. Okay, there are 2 married couples, okay, in the whole family. D is grandmother of A, okay. So D is grandmother of A. Okay. D is grandmother of A and mother of B. Okay. So D is mother of B. So this is the grandparent layer, this is parents layer, and this is child layer. Then the second point is this was the first point. From here, second point starts. C is wife of B. C is wife of B. Okay, so C is wife of B. So she will be in this layer, parent layer. And mother of F. Okay, so C is wife of B and mother of F. Let's do this. And the third point starts from here. F is the granddaughter of E. F is the granddaughter of E. So F is the granddaughter of E. So F has some grandparent who is E. And then the fourth point is B is the only son of D. B is the only son of D. So we know that B is male. It is son. It's male. And then A is grandson of E. A is grandson of E. So he is also male. A is also male, son. How is A and F related? So as A is grandchild of D and E, both means they are married, and then these two are married. So according to the question, we have these 2 married couples, and then this is the boy, means this is the father of A. This is the female wife, as C is wife. So this is female, and this is also granddaughter. It was said like F is granddaughter of E, means this is the girl. And they asked the relation between A and F, so like A is brother of F. Yeah, correct. Yep, so brother. Got it. Let's move on to next question. Quickly read it and try to solve. This is related to profit and loss, and it has 2 concepts in it: profit and loss and simple compound interest. So mixed question. So let's start. A shopkeeper marks an article 50% above its cost price, okay, and sells it after allowing a discount of 20% on a marked price. He then invested the total profit earned from his transaction into a scheme offering 10% compound interest, compounded annually for 2 years. If the total compound interest earned from the scheme is 1344. Okay, so this is the compound interest 1344. Find the original cost price of the article. Fine. So let's start from here. A shopkeeper marked the article 50% and above its cost. Okay, 50% above its cost price. So let's consider cost price as 100x for easier calculations. And then he increased the so he had MRP, maximum price, marked price, as 50% more than this. So into 50% more. So it can be like we can multiply it by 1 by 5%. So it's like 150x. 150x is the MRP, right? And sell it after allowing a discount of 20%. Okay, so 150 is MRP, then he gives 20% discount. So what's the 150x 20%? 20%. So what's the 20% of this? It a discount of 20% on the mark price. Okay, let's, yeah, we got answer from Vikas. Let's see. Is it correct? Okay. So here it sells it after allowing a discount of 20% on the marked price. So our marked price is 150x. We calculate 20% of 150x. I think everything is fine, I guess. Let me just 150x into 20%. One by five. 5 ones are 5 threes are sorry 30x. This was the wrong calculation. So 30x is the discount and the mark price is 150. So our selling price is 150x minus 30x equals to 120x. So 120x is the selling price. Fine, he sold at 120x and his cost price was 100x, right? So what's the profit? Profit is like selling price minus cost price, 100 minus 120, it's like 20x. So this is the profit. Now he took this profit and invested into a scheme where he got the interest, compound interest of 10% for 2 years. So we can like use the compound interest formula. Compound interest equals to principal into 1 plus rate of interest by 100 by, by time. How much time? So let's like t minus 1. You can also do it without formula simply because it's just 2 years. So you can just calculate 10% and then 10% plus the 10% on the 10% we got from first year. So it's also one way of quickly solving it without formulas, but we can use formula as well. So 1344 is the compound interest we got finally, right, after 2 years. Principal was 20x. 1 plus rate is 10 by 100 time is 2 minus 1, right? And then it's like 11 by 10 square minus 1. So it's like 21 by 100 because we are doing square minus 1. Here it's 20x. Sorry. So just, okay. I'll write it here. Small area. 121 minus 100 by 100 we took LCM. Oops. And then 20x. So it's like, sorry, 20x into 21 by 100. And this is equivalent to 1344. And we just need to calculate x here. Okay, let's write here. You guys can see answer is 32. Whoever calculated because is right. Just 1344 equals to 20x into 100 by 21. When you solve this, as you already know the answer, the x is actually 320. And we calculated our cost price initially as 100x. We assumed it as 100x. So x is 320. So the cost price of the article is 32,000. And let's move to next question. It's 9th question, guys. So yeah, we'll be done quickly. Sorry, the session was too long today. Quickly read this. In how many days can Arun complete a project alone? Okay. Statement 1 is Arun and Bhuvan together can complete the project in 12 days. Second statement is Bhuvan takes 10 days more than Arun to complete the project alone. Okay, so the main question is how many days Arun can complete the project? So to answer this question, how many statements we need? So let's try with first statement. So Arun and Bhuvan together can complete the project in 12 days, right? So maybe like efficiency of Arun plus efficiency of Bhuvan equals to efficiency of Arun alone plus efficiency of Bhuvan alone equals to efficiency of Arun and Bhuvan together. So maybe like if we consider work done as 1 by A plus 1 by B equals to 1 by both works in 12 days. So time taken by both together is 12 days. So this is one equation. There are two variables A and B, and we can't solve two variables just with one equation. So just statement 1 is not sufficient. But statement 2 says Bhuvan takes 10 days more than Arun. Means Bhuvan takes 10 days more than Arun. So we got a statement 2. This also alone is not sufficient. We need both the statement to find out A and B and how much time Arun takes, so that both statements are required. Yeah, I can see answers in chat. You are all right. Both are sufficient. Fine, let's do the last question quickly. It's related to sets. In a survey, 500 people regarding their subscriptions of 3 OTT platforms, Netflix, Prime, Hotstar, it was found that everyone subscribes to at least one platform. Okay, so all 500 people have at least one of the subscriptions. So let's quickly solve and let me know in the chat if you have solved. So let's consider it as Netflix, Prime, Hotstar. And then the number of people who subscribe to exactly one platform is 200. Okay, so exactly one means this region plus this region plus this region. The sum of these three region people are 200, which have using just one platform, exactly one platform, right? And then the number of people who subscribe to all three platforms. So this region is 50, all three platforms. Understood? From the diagram visually, you might get better understanding. The number of people subscribing to only Netflix and Prime. Subscribing to only Netflix and Prime. So if this is Netflix and this is Prime, so this region, right? This region is only Netflix and Prime is equals to number of people subscribing to all three. Means this region is 50. They're telling like this region is 50. And then the next statement is the number of people subscribing to only Prime and Hotstar. Prime and Hotstar is twice the number of people subscribing to all three. Means this region is 150. Oh, sorry. Twice means 100. 100. Got it? So find the number of people who subscribe to only Netflix and Hotstar. Means we need to find out people in this region. Did anyone got the answer? And all 500 people are in these three circles. No one is outside because everyone is subscribed to at least one platform. So if we just sum it up, so this region is 200 plus we have 50 of this, then 50 of this, all three, and then 100 of this region. So how much is that? 200, 250, 300, 400. So this these all places are occupying 400 people. Just this place is left, which is 500 minus 400 means 100 people. So this region, like only people having only Netflix and Hotstar are the 100 people. Yeah, correct, Vikas. And hope others would have also understood the question. So we are done with our LR segment. Now I'll give turn to Sarashish. If Sarashish is here, it's 11:30. We started at 9, right? It's around 2.5 hours. Sarashish, are you here?
Yeah. I am here. Just a minute. Yeah.
I'll stop sharing.
It's okay. So, yeah, guys, it's almost time. Like, we have done, I guess, 11 questions about LR, right? And you have already done 5 to 6 questions on maths. So, this will be the last stretch. Sorry for the timings, actually. So, it has been stretched a lot. So, we will try to cover the next 4 to 5 questions for maths as quickly as possible, but still we won't try to compromise on the quality, but still we will try as quick as possible so that you can properly live and also prepare for the upcoming exam. So yeah, let me share my screen first. So till now, how many people are still here? I guess 1 or 2 actually left. But if you are still here, give some reaction so that I can understand, okay, some crowd are still here. Okay. Great. Great. So right now we will focus more on the remaining things, which is one is number theory. Of course, number theory, there will be 2 to 3 questions on number theory. And other than that, there will be one question on logs, and the other question is on ratio proportion, right? Again, we won't deep dive on ratio proportion that much because again, that is already covered on LR part. But still, as maths also, sometimes they give ratio proportion questions. So we will see one or 2 questions regarding. So let me share my screen quickly and so that we can directly start. So yeah, guys, let me know if you can see my screen or not, and I'll maybe do one thing. I'll join from mobile too, so that I can see your chats. Just a moment. So yeah, so just a minute. Mm, okay. So let me just open the chat. Yeah, I think I will be able to see your chats now, guys. So let's start with the questions directly. So the first question is of GCD, right? HCF, LCM, very commonly asked topic in number theory. So given that GCD of A and B is P square, where P is a prime number, how many distinct values are possible for GCD of A to the power 8, comma B to the power? I actually planned this lecture so that we will solve it together, and then I'll give you some 2 to 3 minutes time to solve these questions, as these questions are very much important, and then we will discuss it together. But right now, I think we are a little bit uh, and a little bit long. This actually session is a little bit longer, so maybe we will not do that. But let's directly start with the solution. So again, give me some reaction if you guys know the intuition behind how to solve these problems. Great, great, great. Have you? I hope that you have lecture. You have watched the lecture, the HCF lecture, which is the second lecture of number theory. There we have covered this type of problems also. But again, yeah, this is one of the very important problems which we will see actually. Now GCD, right? GCD. What GCD means? Greatest common divisor, or ACF. Same thing, right? Highest common factor. What actually means A comma B, there are some common parts. There are some common factors. The greatest common factor is GCF, GCD, or HCF, right? Highest common factor, greatest common divisor. Same thing, right? Now, now it is said that there is arbitrarily two numbers, right? A and B. And the GCD of A and B is P square. So as GCD of A and B is P square, we know that in both these numbers, P square is there. P square is present, right? So can we write A something like this? P to the power K, let's say P to the power X, right? And then maybe some arbitrary number N. And B, P to the power Y, N, right? We can write it like this. Because why? We know that for sure there will be some P in A and some P in B, because GCD of A and B is P square, right? Now, but we know that GCD is P square. So tell me something. As we know that GCD is P square, so at least 2 should be there in both A and B, right? At least 2 should be there in both A and B. P to the power 2 should be there in both A and B. So can we say that? Can we say then that the minimum of X and Y should be 2? Because let's say if X is equals to 1, right? Y is equals to 4. We can only take one P common. So then the GCD would be P, not P square, right? So, but in our case, the GCD is P square, right? So the minimum of X5 should be 2, right? So we can write it properly. GCD of A comma B equals to P square. A equals to B to the power X, and M B equals to B to the power Y, and again M and N are co-prime. co-prime. Why co-prime? Because um, why co-prime? Because again, we have directly taken all the common factors here. So there, here there should not be, there should not be any common factors, right? So now, but again, this is not that much relevant. But again, just I mentioned. Now, this leads to minimum of x comma y equals to 2, right? Now, now here there can be some cases, right? What can be the cases? Either x can be equals to 2, right? Either x can be equals to 2. Now, in this case, y can be equals to what? Greater than equals to 2, right? Y can be either 2 or greater than equals to 2, right? Y's options can be 2, 3, 4, etc., right? Now, let's try to find GCD of this a to the power 8, b to the power 4, right? When we are solving for this case, right? So, case x equals to 2, right? Now we will see what GCD can be. So y3 can be a case, right? Y2 can be also a case, right? Y2, let's say for y equals to 2, right? First, so GCD of a to the power 8, b to the power 12, right? Will be again, so will be equal to what? We can directly see a to the power 8 is equals to nothing but p to the power 8x, right? N to the power 8. P to the power 12 can be p to the power 12 y n to the power 12, right? Now, so you can directly say that, okay, the GCD will be either this or this, right? So can we write this minimum of 8x, 12y? Do you guys have any problem regarding this? Because again, this was the same thing, right? See, here we written that only. The seat of AB is p square, then minimum of xy is 2, right? The city of A people is will be what? Minimum of 8x, 12y. 8x and 12y. Minimum of these both. Because why? Because again, these two are co-prime. Co-prime. So these do not have any common factors. No common factors. Right? So we do not care about MNN, so right? So GCD will be mean of 8x and 12. Now, as we have established this thing, right? We can directly plug in values, right? So 8x will be nothing but 16. For this case, it will be 16, 12 into 2, 24 minimum, which is 16. So this is one option. This is one GCD, possible GCD, right? Now, can we do y equals to 3, right? We can, as simple as that, we can do y equals to 3, y equals to 3. So, if it y equals to 3, then what will be there? We will directly write min of 8x and 12y. Now, the x will remain 16 as x equals to 2, but the y will actually be more, 36. But again, min is there, right? Again, it will be 16. Now tell me, if I increase y, this part will always remain 16. This part will increase. But the minimum will always be 16, right? Minimum will be always be 16. That's why 16 will always be the answer. No matter how much I increase y. As simple as that. So can we directly say that for x equals to 2 and y equals to greater than equals to 2, there is only one option, which is 16, right? Now we'll see the next case, right? We'll see the case 2. Case 2, where y is equals to 2, x can be greater than equals to 2, right? Now, let's start with, again, x equals to 2, we have already calculated, we want, right? So x equals to 3. X equals to 3. For x equals to 3, if we find minimum of 8x, again, 12y is nothing but 24 And now 8 into 3 is 24. 12y into 2 is 24, right? Minimum. Now it will be what? 24. Now this is another unique number we got. Still now we got 16 and we got 24, right? Now after that, if we increase x, right? We do x equals to 4, y equals to 2. So minimum of, again, y equals to 2, right? This will be fixed 24. And now x will increase. X will be, now x is equals to 4. So 4 into 8 will be 32. But again, see, no matter how much x will increase, y will be remaining 24 only, right? So the minimum will always come out to be 24, right? So is there any point increasing, going on increasing x after than this? So x to the power 4, 5, 6, 7, it will all be 24 because the minimum is 24, right? Because y is not changing. Again, both cannot increase because then the GCD will change. So x and y cannot be 3 together because the GCD will change, right? So we need to keep the GCD the same. So there are only two possible answers, which is 16 and 24. So the count is 2. So this is actually how we can solve this thing, right? So yeah, the answer is 2. Any doubts regarding this? Yes, Vishwa, the answer is 2. Harsh, no, 7 values, it's actually not the correct approach. Maybe you did some mistake somewhere, but no, it will be restricted to 2 values only. Because always see, the minimum gets restricted and we cannot increase both the variables, right? So that is why it will remain as 2. Okay, so 16 and 24 are the unique values. So how many distinct values are possible? Only 2, right? Any doubts? Any doubts? Please give a reaction if you all
Yeah. Hello.
Yes.
I have a doubt. So, in the first case, we consider that x is equal to 2, right?
Yeah.
In the first case. So, in that we will get 16 as answer, right? So, y could be like y could be 0, y could be 1, y could be 3, right?
No, just a minute. Here, if you think, let's see. First of all, the condition is minimum of x comma y should be 2. So, if you put, so if x is equals to 2, right, and y equals to 0, then the minimum of x comma y will be 0, not 2. So then it will violate this condition.
Yeah, got
So
it.
you cannot put y here. Y equals to 2.
Mhm.
So when actually putting values in minimum functions, you need to also remember that both x and y must be greater than equals to 2 at least. Because again, the minimum is 2. You cannot put 0. Got it?
Yeah. Got it. Thank you.
Even if the values of 8 and 12 change. Sorry, didn't get your question by the way. Even if the values of 8 and 12 change. So are you saying that if the power changes, possibilities will only be 2, right? If that is the question, so if the powers change, then the two only. That actually depends upon the powers also, because sometimes, let's say a power is very much small, right, and a power is another power is very much large. So in case of some arbitrary number, so this is maybe 2, this is maybe 20, right? Then I can have many, so 2x and 20y. Then I can have many x and y's, right? For a single y, I can have many x's. So that in that cases it can change actually. So do not think like this. Try to solve it using cases, and whatever the answer is, that will be your answer. So there can be much more than 2 cases sometimes. So this is the case. So if you see, this will be, if the question was minimum of 2x and 25, right? Then we could have plugged in many more values of x. Then it will be, if let's say right now x and y, they both must be greater than equals to 2, right? So if y is equals to 2, then x can be here 2, then 3, 4, 5, right? 6, and I think until 9 or 9, 10, I think up to 10 it can go, right? So we can have actually these many unique values. So this can also happen, right? So this is not the only question, but this can actually also happen. So you can have multiple GCDs. That's it. Hope, Deep, I guess your doubt is clear, right? Great. Okay, so let's move on to the next question. Now, this is again another HCF LCM kind of question, but this is actually different from the last question. So this also has a perfect square concept. A little observation actually, I'll say. So a natural number n satisfies these two things. LCM of n, 360 is 360. HCF of n, 360 is a perfect square, which is greater than 1, right? How many different values of n are possible, right? So, again, what does actually LCM mean? LCM means LCM lowest common multiple. So LCM of AB means if let's say LCM of AB is some number m, right? Then what will be our point is m divisible by A and B, right? And m is the least number, right? This is the thing. So this is kind of the concept of LCM. So what we can say is in LCM we will of A and B we will have all the factors of A, we will all have all the factors of B, and it will be something like that, right? So we can think like this. Now, now understand this. Now if LCM, right, LCM of n, 360 is actually 360. What does that mean? That means is that n is divisible, n is a factor of 360. Is the answer 3? We will see. I think maybe you actually is correct, but we will see. We will fully solve and we will see. So by this term, we should understand this, that n is a factor of 360. Why? Because because if both of you understand this again, 360 divisible by 360, right? Also 360 divisible by n, right? So from here we can also conclude n is a factor of 360, right? Simple LCM deduction. N is a factor of 360. Now let's try to figure out what HCF can be, right? Now as we know, n factor of 360, right? Now HCF of n comma what? It was 360, right? 360 is what it is. We need to see actually what it is. So now, as we know, n is a factor of 360. So what can be the highest common factor of n and 360? N itself is a factor of 360. So directly this will be HCF or this can be n. As simple as that. Because we are saying that n is a factor of 360. Now what will be the HCF for n and 360? N, if let's say the factor was some 6, right? 6. So if HCF of 6 and 360 is there, that will be 6 direct. Why? Because 6 is a factor of 360. So that can be the highest factor of 6 and 360, which divides both 6 and 360, right? As simple as that. So HCF of n and 360 is n, right? Now, so ultimately my question boils down to this. Two things. This is factor of 360 and this is a perfect square. Right? Ultimately my question boils down to these two. Right? Now, as n is a factor of 360 and we need to find like all the possible combinations, right? What should come into our mind? Factorization. Right? 360 is nothing but 36 into 10, 6 square into 10, which is nothing but cube into 3 square into 5, right? 6 to 2 and 2 is 1, 3, okay, 3, 3, yes. This is 2 to the power 3, 3 to the power 2 and 5, right? Now we got the factors, right? Now understand this. We have the second case of perfect square. Now, important thing to note about perfect square is what? A perfect square always has all the prime factors have even exponents. Why? You can ask me why. Because it is a perfect square, it happens how? So think about this. So in perfect square, what we need to do? There is this number which is actually perfectly multiplied, right? So can we say this number this number can be perfectly divided into these two numbers? These factors of these number can be perfectly divided into these two numbers so that both these boxes have the same factors. So if we need to perfectly divide, so if we do not have even pairs of factors, how can we perfectly divide it into two boxes, two identical boxes? Right? We cannot. So that's why we need to have even numbers, even powers, right? So, so let's try to see, right? 2, 3, and 5. Let's try to analyze 2, 3, and 5. Now, also one thing to note: 0 is also a legit power, right? We will see now. 2. 2 has the ultimate power as 3, so it can have 0 and 2, right? 3 has 2, right? 3 has power 2 and actually there, so we can have 0 and 2, right? 5 has power only 1, so it will be also limited to 0, right? So we have two ways, and only one ways, right? Now, what we will do, the answer will be the multiplication, right? 2 into 2 into 1, which will be 4, right? Why? Because as simple as that. There is two ways, and then one way, right? So we have only these number of things. So we will multiply it to make the whole number. That's why multiplication is used. And 2 into 2 into 1, basic principle of counting gives us 4. Now, tell me, is this the right answer? In the comments, tell me, have you understood? Okay, no. Any other person who thinks it's yes or no, yes or no? Patel 50 is actually not the answer. Anyone else who thinks that this is no? With the sum of even exponents. Why did you do the sum of even exponents? So I'll get to you, I'll get to your doubt. Okay, no. Okay, yes, this is actually not the correct answer because we missed an important thing. Which is what? Greater than 1. So in this combination, there will be a case where we will have 1 as GCD. So we need to ignore that case. So that will be 4 minus 1 equals to 3. So 3 will be our answer. Now everyone is clear. Anyone has any doubts regarding this question? Please give thumbs up if you have understood the question. Great. So okay. Okay. Now let's go to the next question. Now this is a very interesting question, by the way. And actually I'll show you two ways to solve this. This question will take a little bit of time, but it is very much important to show you both the ways. So that in exam, at least if you think that, okay, by this way I cannot solve, so at least in your mind the other way comes around. So that's why I'll show you maybe two processes to do this, right? First will be a little bit lengthy process, but more intuitive. Second will be very interesting process. So yeah. And by the way, today's today's number theory lecture will also have, we will talk detail about remainders and all. I have already tried to upload the lecture. It will get uploaded. It is giving some errors. I'll check after this session. It will get uploaded. Please do watch that lecture. It is fully about remainders. These are almost 2 hours 30 minutes lecture, but you will actually like it. So yeah, let's start with this question. And by the way, just to for context, as this will go on YouTube also. So for those of you guys who are thinking what lectures I am talking about, so in our elite course, we basically teach people direct concepts, and we have dedicated lectures toward that. So I'm talking about those lectures which actually are available on our platform for our paid customers. So if you guys are interested on checking out our courses, please do check out on our website. So anyways, let's start with the question. A number n is formed by concatenating all odd integers from 1 to 99 in increasing order, right? So n is equals to what? 1, 3, 5, 7, 9, 11, 13, 15, something like this, right? This will go on. Now, what we need to do? We need to find the remainder, and n is actually divided by 9, right? Now, this is a little bit on a harder side, but actually you will have much more learnings from this. So follow along, and also try it if you think that if you have any idea to solve this question. So yeah, now as we know the divisibility rule of 9, when I explained divisibility rule of 9 in our lecture also, what we noticed that we need to only focus on checking the divisibility for the sum of the digits, right? We need to only focus on checking divisibility for the sum of the digits. So we focus that what we stated there as if A, B, C, D is the number, then if A plus B plus C plus D divisible by 9, A, B, C, D also defined, right? But remember this, in that lecture, what we tried to prove was that this whole part, there was this whole part of, let's say, if an arbitrary number, I could, like, I will not take the exact number, 9 plus 9 B plus 9C, right? This whole part was actually divisible by 9. And then this was A plus B plus C plus D, right? Here. Now notice why I am bringing this back is because notice that this is always divisible by 9. So I do not care about, even if I want to find the remainders also, I do not care about that part because that part gives us remainder 0. So this part will always have remainder 0. So we do not care about this part. We always care about this part. So even if we do not need to find remainder also, we will only focus on A plus B plus C plus D for cases of 3 and 9, right? We will only focus on this one. Now this we established, right? We need to focus on the sum of the digits. So remainder when this will, so this divided, so I can write maybe n equals to this, right? So what can I say? Remainder when n divided by 9 is same as remainder when all the digit sums of sum of n is divisible by 9. Now, our problem kind of got reduced to finding this 1 plus 3 plus 5 plus 7 plus 9 plus... Now it becomes tricky. It won't be 11. No, this is not the correct thing. 1 plus 1 plus 1 plus 3 plus ... like this. Right? This boils down to this thing. Okay. Now, we need to find this summation. We need to find this. Find this. Right? Now, how can we find this? Now, if we properly analyze and count how many, see, we know that in this whole thing, there will be only digits from 1, 3, 5, 7, and 9. So if we can count the number of ones is there, number of 3 is there, number of 5 is there, if we count this, then our question, our sum, we can easily count it without even imagining anything, right? So let's try to do this. Now, now there will be one case where the digit is less, right? First of all, there will be one case where it will be single digit. Now, single digit, we do not care, right? We can directly add the summation like 1 plus 2 plus 1 plus 3 plus 5 plus 7 plus 9, right? It will be 25, right? As again, if you do not know, just I'll mention you. So, sum of odd numbers is equals to n square, and odd numbers is equals to n square, right? So, as we had 5 odd numbers, so it will be 20, right? So, okay, now single digit done, right? Now we will see about double digit. Now, double digit has 2 parts, right? 1, 2. Now, we will consider tens digit first, right? And now, tens digit, how many we have? For 1, we have 11 to 19, right? In between, we have 11, 13, 14, 17, 19. So, 5, right? We have 5. 2, we have 21. Sorry, 2 will not be there, right? 31 to 39, right? Okay, so 11 and 19, right? 11, 13, 15, 17, 19, yes. So 31 and 39, again same, 31, 33, 35, 37, 39. Only these 5 cases will be there, right? Again, it will be same for 5, it will be same for 7 and 9, right? So technically, what this will become is 5 common, 1 plus 3 plus 5 plus 7 plus 9, right? Now this is actually 5 into 25, 25, which is I guess 125. I'm not wrong. Guys, by the way, let me know if I go wrong somewhere. So if you feel like I am going wrong somewhere in calculation. So yeah. Now we will focus on this, the units digit. Now in units digit, how many times it will be there? So units digit, let's think about it. So it will be 11. So first of all, for units digit, if you can see 11, 21, 31, 41, 51, 61, 71, 31, 91, all technically are there. But notice that we actually have already considered some things like 11. No, but just a minute. No, we haven't considered. Yes. So we need to take everything because we are considering this digit as separate, this digit as separate. So we haven't considered. So we need to, my bad. We need to calculate everything. Right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess this will be 9, right? This will be 9. 11, 21, 31, 41, 51, 61, 71, 81, 91. Yes, 9. So again, it will be the same for 3, right? For the place of 3, it will be the same, right? It will be the same. So can I say 9 into 25 easily? So 9 into 25 is what? 225, right? 9 into 25 is 225. How I said 9 into 25 again? It will be the same for 1, 3, 5, 7, 9. So 9 into 1, 3, 5, 7, 9, which is actually 9 into 25, which is 225, right? So now in single, we got 25. In double, we got 125 and 220. So can we make a summation of this, right? Can we make a summation of this? It will be nothing but, just a minute. Where did my screen go? Just a moment. Yeah, I guess. Okay, I'm back. So yeah, it will be what? 25 plus 125 plus 225, right? Which will be equal to what? 150 plus 225, which is I guess 375. 375, right? 225, 125, 25, yes, 375 should be the correct thing. Okay. So 375 should be the correct thing, right? And now, so we got the sum, right? We got the sum. Now, as we said, A plus B plus C plus D. We need to find the remainder of this. Not when divided by 9, right? So 375 divided by 9 is what? 4 9s are 36, right? 15, 1. So it will be what? I'll maybe check just a minute. 15 minus 9 will be 5 minus 4, which is I guess 6, right? 6, I guess. Yeah, 6. Did I do any mistake? Okay. I guess 6 should be the answer. So 375 minus 36, yes, I guess I did the division correct. So, 6 should be the answer. So, I'll just recheck my answer once because I guess I had 7, right? So by the way, I think the answer was 7. But I'll just check once if I had missed any places or something. Oh, yes, I missed actually a case. What was the case? My bad. So I actually miscalculated this part. My bad, guys. A quick correction. Yes. Instead of this being 1, 3, 5, 7, 9, this will be something else. Why? Because understand this. We the 20, right? We will also consider. So this is double digit, right? So we actually need to consider all the digits because 23 is also an odd number. You cannot ignore this two. We cannot ignore this two, right? 23 is also an odd number, so we cannot ignore this two. So for this, it will be the calculation will be a little bit separate. So again, the 5 logic is correct, but it will be valid for 2 also. So 21 to 29, there will be 5, right? So for 4 also, there will be 41 to 49, there will be 5 things. So instead of this, it would be something like, maybe I'll erase it directly. So just a minute. I'll erase it this one. Yeah. So I'll erase it. So yeah, I'll properly paste now. So technically this will continue for 9, right? Till 9. So 91 to 99, there will be 5. So how many 5s are there? 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 into 5 is, so basically 9 into 5, right? No, sorry, my bad. 5 into 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. So 1 to 9, what will be the summation? 9 into 10. 9 into 10. So basically we need 1 plus 2 plus 3 plus dot 9. Right? We need this. So 9 into 10, 10 into n plus 1 by 2, which is 9 plus 45. So 45 into 5, which is what? 225, right? So the answer would be what? 25 into 225 plus 225, which is nothing but 47. Yes. Now the answer is correct. Now, as the remainders will also get changed, I'll maybe erase this calculation for now. Yes. So yeah. So the calculation would be what? 475, 75 divided by 9, which is 5 is 45, 25, and then it will be 2, right? 18. 18 minus 25, 25 minus 18 will be, yes, 7. Yes. 7 is actually the correct answer. The mistake which I did was I directly ignored in the 10th digit also, I ignored 2, 4, 6, 8. So we need to include these also, as 23 is also a odd number. Odd number. 23 is also odd. Okay. So is this clear that the answer will be 7 and this is one of the ways we can solve this? Is this clear? And I hope that my mistake you do not repeat, because that is a genuine mistake which you can make, right? Please give some reactions if you understood this part. Great. Beautiful. Now, as you saw, the process was a little bit lengthy, right? Until here, it was very easy. But then after we need to find this, right? This was very much lengthy. And this could actually be now this will be process 2, right? Process 2. I'll talk a little bit about process 2. Again, if you do not get process 2, it's completely fine. It will be having a little bit of modulo and all, but process 2 will be much easier. I'll show you one. So let's say there is a number, right? So maybe the number can be, wait, what can be the number? Maybe 9, 18, 27. If this is the number, I guess this is divisible by 9. I hope so. Yes, it should be divisible by 9. 9 plus 1, 10, 18, 21, 20, no, just 9 plus 1, 10, 18, 20, 27. Yes, this actually is divisible by 9, by the way. So yeah, let's say this is the number. Now we need to check this divisibility by 9. Now, again, we know that this is the process, right? 9 plus 1 plus 8 plus 2 plus 7, right? But what if I say that this, by the way, I will use this operator, this is known as modulo. This basically gives us the remainder. It will be easier if I use this, okay? So modulo 9. So basically A modulo B means what? Remainder when A is divided by B, right? It's a simple thing, nothing fancy, right? Just use the notation for easier explanation. Now, this is actually equal to 9 plus 18 plus 27. This is actually equal, or for that matter, 91 plus 82 plus 7, 9, or any combination, like any proper combination. So 9, 1, 8 plus 2 plus 7. Now, how this is happening, I'll explain a little bit, but not much. So let's see about 9, 18, and 27. 9 plus 18 plus 27. Or maybe let's take another number, only two numbers, 18, 27, right? It will be easier to explain to you guys. So mod 9, right? Now, earlier we knew that something, let's say anything like maybe 27 mod 9 also means 2 plus 7 mod 9. This we knew, right? This we knew. Why? Because the number mod, the remainder of the number is equals to the remainder of the number, sum of the digits of that number. It is basically the same thing. I have written in mod, just that, right? 18 plus 27 mod 9 is what? Can we write this? So 18 mod 9 plus 27 mod 9 mod 9. Now there is this property of A plus B mod M, which is equal to A mod M plus B mod M. This is actually a very easy property. This is nothing fancy, because if this remainder plus remainder gets added, we will take the whole remainder to get the full remainder. It's actually a very easy thing, but I'll still not go into how that thing came. You can refer to in my lecture, which will be uploaded. Okay, sorry. So again, so this can be what? Now, as we wrote this, can we write this the same way? So 18. So can we break 18, right? 1 plus 8 mod 9 plus 2 plus 7 mod 9 or mod 9, right? And so can we write this 1 mod 9 plus 8 mod 9 plus 2 mod 9 plus 7 mod 9 whole mod 9. So technically, is it same as 1 plus 8 plus 2 plus 7 mod 9? Did you understand this? Did you understand this? From 18 plus 27 mod 9, I went on to the sum of digits mod 9. Right? Now, why I did this? It is because if we can prove this, that for any combination, if we add the sum and then take the mod 9, it will be the same. Then we can cleverly separate something. So our n was what? 1, 2, 3, 4. Sorry, my bad. It was not 1, 2, 3, 4. 1, 3, 5, 7, 9, 11, 13, 15, 17, right? It was till 99. So instead of taking 1 plus 3 plus 5 plus 7 plus 9 plus 1 plus 1 plus 1 plus 3, all these things, what can we simply take? We can simply take 1 plus 3 plus 5 plus 7 plus 9 plus 11 directly plus 13 plus 15 plus 17. Just now we proved this. Just now we proved this. Right? We can, instead of this, we can take this. And what is this? Sum of n odd numbers. Now, from 1 to 99, how many odd numbers are there? 50. So, it will be nothing. Then the sum of 1 plus 3 plus plus 99 will be nothing but 50 square 2500. And now we need to take, as we got this sum, we need to basically take this modulo 9. 9 will be equal to again what? 2 plus 5 plus 0 plus 0 mod 9. This 7. Here is the answer. If you would have known this, this would be a one-line question. How? As simple as that. N will be equals to what? This whole 50 square congruent to 2500 congruent to 7 mod 9. This is the solution to the whole problem, a one-line solution. Even if you haven't understood this thing, it is completely okay. Okay. Though, don't think that you do not do using mods, you cannot actually understand things or you cannot solve things. You can use the same logic that you have used earlier to solve this question. So it is completely okay. Any doubts, by the way? This is a tough logic, I agree. Yeah, it's okay. You can use anything. It's completely fine. Or sum of odd. There can be multiple ways to find sum of odds also. Yeah, also if someone does not remember n square or this formula for sum of odd, they can also do this, right? At least we all remember sum of n numbers, right? So sum of first n numbers, so it will be n into n plus 1 by 2. But now we need to remove all the even ones, right? Minus. Now 2, 4, 6, 8, these all are even. Now if I take 2 common, it will be 1 plus 2 plus 3 plus 4 till 50, right? So technically that is the case. So actually we can directly write this as 100 into 101 by 2 minus, we can directly write 2 into this thing, 50 into 51 by 2. If someone does not remember any formula other than this, n into n into n plus 1 by 2, then still they can also easily find this. So it's completely open. So just I use this for sum of odd, but did not got the answer. So is your sum of odds wrong? Or check the formula. I don't remember. What I remember from the odd formula, that was this n square thing. N square. This is a very common pattern which we find it. So if there are 50 odd numbers, then it is simply 50 square. So do check out once if your formula is correct or not. But if you properly calculate the sum of odds, this the answer will be 2500, and then again 2500 mod 7 is just 7. That's it. That's the answer. So just check out that you have done the formula properly or not, or whatever the case is actually. But yeah, and also I think n square is a pretty easier formula to remember also, and it actually works on many patterns. So yeah, check once. And if still you are getting some errors, please send a message in the group, and we will with your actually the solution which you did in your copy, and we will try to see what the problem is later on, right? Now as we completed number theory, we will see this is actually ratio conclusion, right? I'll give you guys 2 to 3 minutes to solve this at least, because I hope that you can easily solve ratio proportion question, because after that there is a log question and then we are done with this. So yeah, just take 1 or 2 minutes, very easy question, just try to solve it. Fast, very fast, okay? Please, because we don't have that much time. And please give a reaction if you are trying to solve. Great. Solve it quick. Quick answer. Anyone got any answer or is doing it? Fast. So I'll still read the question for you guys. Till then you try to solve. So a construction project manager has 36 workers. Right? The worker is 36 for a site with a total wage fund of 54,000. So this is the total fund. 25% aside for materials and logistics, and the remaining amount is used to pay the workers. So 75% which is remaining is used to pay the workers. The workers consist of skilled workers, and helpers in the ratio of 5:4, right? And the wage per person for skilled workers and helpers is in the ratio 4:3. What is the average wage in rupees received by each skilled? So I hope you have tried or you are trying this question. I guess this is easy, so we can solve it parallelly also. So you guys try to solve your own, and I'll maybe continue with the solution. So first of all, note that we have a fund as 54,000. So 54,000, right? This is the fund. Now, we set aside 25%. So what we set aside 25%. So how much amount for wages remain, total amount for wages? So this is actually total fund. So fund for wages will be what? 3/4. 75%, right? 3/4 into 54,000. Right? 3/4 into 54,000 is what? You can directly calculate, I guess. But right now I don't have calculator with me. But 1 then 1, 2, no, 1, say 1, 14, 14 into 3, and 5, 0, 0, into 3, which will be what? 3, 3, 9, 3, 4, 0, 5, 0, 0. Yes, this will be the number. So fund for wages is 40500. Now we found this fund for wages, total fund for wages. So also write total fund for wages, right? Now we have total workers as 36. 23142.85 Harshvedani is saying. We will see. Let one or two people also other than you solve this, and then we will see. So until now, I hope this is clear. Very easy reduction. Now we will write it somewhere. Total is 40500. Now also total worker is what? 36. Also another thing, skilled to helpers ratio is 5:4, right? Skilled to helper is what? 5:4, correct? So skilled helper 5:4. So I'll solve this by parts. So total parts will be 9, and so what we can do is number of skilled will be 5.9 into 36, which is 20, as this is 4, and number of helpers will be again 4/9 into 36, which is what? Again 4 into 4 is 16, right? So now we know that we have 20 skilled workers and 16 helpers. Now we know this, right? Okay, Mehtani, we will see. Let others also try to solve, and then we will reveal the answer. So now 20 skilled workers and 16 helpers we have. Again, total fund is 40,500. This we know, right? Now notice that what is the wage difference? So what is the wage? See, yes, skilled to helper is 4:3. So wage skilled to helper is 4:3, right? This is the thing, 4:3. Now we know this. Now we can assume, say, so let wage or skilled be 4x and helper 3x, right? Can you do that? Now total wages paid. How then we can calculate? We know that we have 20 skilled workers, right? So this is, by the way, of one skilled worker, one helper, right? Now 4x, 1 and 2 we have 20 plus 3x we have 16 equals to 40500, right? So 80 plus 80x x plus this will be 63 the 48x equals to 40500, and 80 and 48 will be what? 128x equals to 4050, right? Okay. Now 128x equals to 4050. Now we have this. So can we get x? Simply 40x will be what? 40500 by what? 128. I will still not calculate what is this. I'll see if we can cross it. So average wage received by each skilled worker. So we want skilled workers rate wage, right? So what will be the skilled worker wage? 4x skilled worker wage, right? 4x, which will equals to 40500 into 4 by 128. Now we can basically calculate. So 128, 4, I guess 3, 2, now this could be 52, right? Now this is 2 to the power 5 and 40500 has how many roots to check there? 40500 is this division by 4? It should be yes, of course. 405, so 405 into 25 by 8, right? So again, we will maybe use the calculator to do this horrendous calculation. So 40500 by 32 leads to 1265.625. So this actually leads to what? 1265.625, right? And now this is the answer. Yes. And if this is rounded to 3 decimal places, then this is the answer. Rounded to 2, then 1265.63 is the answer. So 2 decimal places. Okay, this is how it's. 1265.625, yes, very good. Mathani, please check your solution. I guess maybe you have made some calculation mistake or something like that. Try to check your solution. And again, if you cannot properly understand where you went wrong, please after this session, maybe again, it happens. So please do not make these calculation mistakes because this can cost you very much high price in your exams. So please do not do this. In ratio proportion questions, there can be actually many calculations, especially in permutation combination questions also there can be horrendous calculations. So please, probability questions again. So please do not do these mistakes. Have patience, right? And it's okay. You can do that. I know. So the answer is 1265.63 or 625, whatever. It's okay. So and this is actually the last question. We will move on to the last question. So this is during an advanced mathematics practice session at St. Thomas Senior Secondary School, Kochi. The mathematics teacher, Mr. Arun, posed the following question to his students. How many integer values can x take if log base 10x square minus 6x is less than log base 10 30? Right? So again, you don't have much time, so I'll start maybe solving directly. But again, do you now, guys, just let me know, do you think that this is a log? This basically this question has to do a lot with logs. Do you think that? Write in chat yes or no. No, okay. One no, anyone yes or no? Okay. No, great. No, maybe no. Okay, nice. It is an inequality question. No, great. You are on the right track. So this question is just the log is just a facade. So actually, this question has nothing to do that much with logs because basically as log is an increasing function. So why we can cut this is because log is an increasing function, but whatever, forget that log base 10 is an increasing thing. But again, we can simply cancel out both the logs and we can have x square minus 6x less than 30. But there is one catch. As this was a log thing, we will have another condition. X square minus 6x must be greater than 0. We will have this catch to this question. Okay. So when cancelling log, do not forget this step. Because log can take positive values. Right? So this should be greater than 0. So this ultimately becomes an algebraic inequality question, and we will see how we can solve it. Again, it's not that difficult. It's very easy. So x square minus 6x can be written as x minus 6, right? X and x minus 6. Now we will see actually how we can So again, according to this condition, so this may be case 1, this may be case 2. Now first we will analyze case 2, right? We will analyze this thing 2. This whole thing x minus 6 should be greater than 0, right? Now the zeros will be either 0 or 6, right? And do you remember this system 0 and 6? So we'll check something 7, right? We will check for 7, 7 into 7, this will be positive, right? This will be, again, as this is positive, this should be negative, this should be positive. They're not wrong. Any arbitrary number will be 2, we can check 2 to 2 minus 6 is 4, so yeah. So by the way, those who don't know this process, we basically check 1. So 0, as we can easily see, 0 and 6 will be our zeros for this thing. And then we check for maybe 7 here, we check for 7. So 7 into 1 is 7, so this is positive, so this is positive. And then we alternately set negative, positive. So this is one trick we use to solve questions. So yeah, yes, you are correct. So either x should be, so this implies either x should be less than 0 or x should be greater than 6. So this is right. Now, we found this solution. Now, what can we do? We have another counterpart. X square, so maybe you can write x square minus 6x, right? 6x greater than, lesser than 30, lesser than 30. So now this can be solved in one, again, as you will have calculator, right? Can directly get the zeros also, okay? There is no problem getting those zeros. So x square minus 6x minus 30, right? Again, this was minus 6x only, right? And this is minus 30, yes, less than 30, right? So less than 0, then you can go on to find the root, right? You can go on to solve this quadratic. I don't think so this can be directly solved. So there is this formula b square minus 4ac root plus minus. So this is, I guess, minus b plus minus. I guess this was the formula. Can you guys write in the chat if I'm right or wrong? I might have forgotten a little bit about the Sridharacharya formula. But minus b plus minus, I think minus b plus minus b square minus 4c by 2. I guess, yes, I have written it correct only. Yes, I was actually going to mention that only. So yeah, so we can do that, but this will actually take more time. So right now we won't do that, as simple as that. So we'll try for some x's. So either x less than 0, right? You can have x equals to, again, we need to satisfy this, right? Let's write it, x square minus 6x must be less than 30. We need to satisfy this. So we can take x equals to minus 1, right? Minus 1, it will work. This is 1, but this will also be 1 and this will work. So this works. Minus 2, 4 minus 4 plus, it works because yes, 4 plus 12 is 16, so it works. Minus 3, again, if you guys do not understand, I'm just putting and calculating it in my head, you can directly do it also. So x to the power minus 1 will yield 1 minus 6 into minus 1, which is 1 plus 6, which is 7. 7, this will be 16. For 3, it will be So 3 it will be what? 9 plus 18, 27, right? 27. Now there can't be more than 3 because it will increase and it will go on beyond 30, right? So for this we have 3. Now for x greater than 6, we can have 7. Maybe we can check a little bit bigger number, 10 or 11, something like that. 10 maybe. Or let's try 11 directly. 121 minus 66 is actually greater than 30, so 11 no. 10, 10 square, 100 minus 60, 40, no. 9, 81 minus 54. 81 minus 54 is how much? 81 minus 54 is somewhere 27, I guess. 27, yes. So 9 is correct. So 7, 8, 9 will be correct answer. 8, 9 would be correct answer. So for x equals to 6, we can have, right? So we can have 3 plus 3. So the answer will be 3 plus 3, which is 6 cases. So 6 is the answer, right? So there are 6 integer values, x count. So are you guys clear? Are you guys clear with the answer? Okay, so again, these things were actually a little bit easier. But so that marks the end of today's session. I know it's been too long, but somewhere explanation were actually needed a little bit in probability and also. So we are trying to keep the session such that even if you have studied less, you can at least attend this session, then you can score at least 30 to 40% of the people. So last year was a marathon stream. Oh damn! Yes, you were there last year too. So yeah, so I think we took the stream for 5 to 6 hours. So it was a very long stretch, and I was the only instructor that time. So attending that live session because all others were busy. So yeah, that was crazy experience in itself. But yeah, hope you guys liked the session, and also please please write in chat if there is any doubt that I can try to solve it right now before leaving here. By the way, Reminder's lecture will come. I don't know why. There is some platform issue. I am trying to upload the lecture for the past 4 hours, but it's not getting uploaded. I'll after this session I'll check it out. Can we get the PDF? Yes, you will get the PDF. Don't worry, you will get the PDF. You will actually get the PDF. Let me close this and just now let me save the PDF directly right now, so that I do not mess up. So just a minute. Save this PDF. Done. So yeah, you will definitely receive the PDF. I have saved it right now. So, and for the rest of the lectures too, for the rest of the parts of Krishna and also Hemkesh, I'll make sure that you get the PDF of the session. Any doubts regarding any topics or anything that you might have that I can solve? Maybe it can be of number theory or something like that. Happy to answer right now so that before before ending the session, we can have a discussion about it. Or any doubts related to anything, if anyone has. I know it's already 50, I guess 12:50. So yeah, everyone is sleepy. But yeah, if there is any doubts, let me know. And if there isn't any in 1 or 2 minutes, then I'll maybe close the session. Also, guys, batao, how is your prep going and all? What are the doubts you are getting normally? Where are you getting stuck? थोड़ा बताओ, and then maybe we can close this session. Maths mock. Okay, so by the way, for maths mock, please attempt the new test papers also. Okay, the test paper 6, 7, I guess, are already live, and by tomorrow we will upload 8, 9, 10 also, so that you guys can get a full test paper prep, and we will have also a revision session tomorrow where also come with your topic doubts. And please, before that session, do attempt, try to attempt all the papers that are available in your dashboard. I think 7 papers are already available. So at least if you haven't like attempted that first 5, attend the 6th and 7th paper because it is more structured for the scalar and set. The first 5 papers were much harder. The next 5 papers will be a little bit less harder, and so I hope that you can score a good amount there also, so that you get a confidence boost also before the exams. That's why we are planning it like that. The first 5 were hard because we planned it in a way so that you get to practice good questions. Now we are planning so that you get to practice scalar-based question. So please do attempt this. It is going good, but statement questions feel hard sometimes. Yes, that is actually where scalar plays. Understand this? That is actually where scalar plays, right? Scalar plays in 2 or 3 things. So again, LR is just going, so you can do it directly. And in maths, scalar plays in 2 places. One is number theory because no one knows that much about number theory because they haven't properly studied it yet. And the second is they play in statements, they play in word problems, they figure out and frame problems in such a way that even if you know the topic, you fumble, right? That is what scalar does. And that is why we are here. That is why we also provide you with such word problems so that you can deduce them. See, some problems which can be very much lengthy. Scalar does give sometimes some problems which are actually lengthy, but if you properly think about some different logic, there it can be reduced much easier in a much easier way. As today's problem, I showed you the number theory problem, right? The odd numbers part. So if you knew that thing, right? If you knew that thing, it would be a 1-minute problem. If you do not know that thing, it would be a 5-minute problem. And that sometimes can make differences, right? So yeah, I guess in today's LR in today's LR live session, they didn't do questions on coding decoding. Okay, I'll check because again, see, LR topics is 17, right? I guess 16 to 17 topics are there, and questions are more based on. See, for the January attempt, we do not have any this year's questions, right? So, okay, I'm talking about NSET bootcamp. Oh, nice. On NSET bootcamp, they haven't given us any questions on coding. Okay, surprising, but yeah, we'll see. I guess Akanshama was teaching. I don't know who's teaching there, but see, again, in syllabus there is coding decoding, right? So we should be prepared for that well, because again, NSET bootcamp is for everyone who is taking NSET, right? But you guys are different, so I guess you should be prepared for everything. So, but it's interesting that they haven't included coding decoding. But yeah, let's see how the paper goes. Because again, this is the first attempt of this season completely, right? So it is very hard for us also to predict everything because we haven't seen the thought process of this session. The questions were easy compared to Delta questions. Of course, I see the questions will be much more easier. Maybe some questions will feel hard. We are preparing you guys for to maximize all the output, right? So yeah, they are very yes. Normally, in NSET, see, the point is we do not know how much scalar will actually give the test, because normally what happens is that the difficulty level is always much more higher than what they teach in sample test papers also and in bootcamps also. So it's completely okay if so. And the second point is, if you prepare for hard questions, you will learn much more better, right? So that for easier questions, you will always have that confidence. I have solved these hard questions, right? So always, so I can easily do that. So if I solve 5 hard problems from Delta mock test, I can easily go and do 10 mock tests, 10 questions on scalar. So don't worry about that. Yeah, but right now, as you have 1 or 2 days remaining, please try to solve the other test papers that we are giving right now, because that has a little bit lesser difficulty level questions, so that you guys can mass prepare those questions so that you can be fully prepared for the this attempt. And I want every one of you guys to get at least NSET, because NSET is easy. I can agree that okay, interview sometimes this is the first time, so people fumble and all. NSET can be done. Okay, NSET can be done. If you have watched the lectures, if you have practiced, NSET can be done. Okay, so let's try to crack it this time only. So yeah, won't take much time because it's already 12:55. I will also have to think about how to sleep now, as my sleep is gone. But it's okay. So hey guys, let's wrap up the session here. Hope you guys liked it. Please give some thumbs up if you have liked it, and also give us feedback on how the session went and where can we do better. With that being said, bye bye, and keep learning. Watch football match. Oh damn, I don't have the energy right now, but it's okay. Chalo. Good night, guys. Go prepare. And set is 1 or 2 days away. Go prepare. Do not watch football match. Okay. Good night.